Okay. Good afternoon, everyone, and welcome to the 2021 Lessons Learned Workshop. We are excited to bring this training opportunity to you today to discuss some of the challenges we experienced over the last year and, opportunities to learn from them and, make improvements as we take our projects going forward. So my name is John Cariano. I am the support engineer here at DelDOT, and I'm going to be facilitating this event again. Like the winter workshop, we're going to do this over 2 half days. Today's session will run to about 4 p.m. Tomorrow, we will start at 8 a.m. and run to about noon. So at this time, I'm going to turn it over to Todd Revis to talk about the Zoom platform.
Welcome to the 2021 Lessons Learned Workshop. Keep in mind, we're encouraging use of the Q&A function within Zoom for any questions you might have. Due to audience size, we feel this will be easier to manage, and we have quite a few panelists lined up to answer any and all questions you might have. If you'd like to view closed captioning, please click the CC button at the bottom of your screen. We're also recording this event, and we'll be posting it to the DelDOT YouTube channel afterwards. Thank you.
Thanks, Todd. If you've requested a PDH certificate from training, there will be an evaluation form sent to you after tomorrow's session. That will be due to be completed by Friday, March 12th. If you're logged in under a different phone number or name as to what you want or your registration was made in, you'll have to reach out to Sandy Wolf and indicate what that other phone number or name was. So again, that evaluation is due March 12th. So at this time, I'd like to turn it over to our Deputy Secretary and Chief Engineer, Shante Hastings, who's going to make a few opening remarks and discuss our role in being good neighbors.
Thanks so much, John, and welcome everybody. What a year we've had. Pretty crazy to think back to this time last year, all being together and what has transpired since that time. But I want to say thank you for continuing to deliver on our mission, really, to provide excellence in transportation for every trip, every mode, every dollar, and everyone. Danny, are my slides? You can get to the next one. So just a huge thank you. It's been a tough year and everyone has really stepped up to the plate in so many different ways. So I thought in order to welcome you to this Lessons Learned workshop that we would talk about our top 10 lessons learned from the last year. And they're in no particular order, I will admit to that. But just some highlights of things that I think are important for us to acknowledge that we've learned along the way. So number 10, woo, telecommuting. We did it, guys. We did it really quickly too. But we also have to acknowledge that not everybody has the opportunity to do that. And so because of different job duties, so we've had to make this kind of dual virtual and in-person life work, but we've done it. We also acknowledge the fact that some things still have to be done face-to-face. And sometimes it's nice to just be able to see a face every now and then versus on a screen. But we've done the telecommuting thing. We'll see where we end up with it as time goes on. But kudos to those of you who have been able to do it while having the burden of other responsibilities, including trying to teach your kids from home, from caring for parents, from just being anxious about everything and still ultimately being able to do your job. The next thing that I'd like to highlight is just the whole fact that we went virtual with Project Status, which seems pretty crazy when you think about it. We were all very used to being in, whether it be the Dover room or the Farmington Felton room together, seeing faces, being able to kind of work through our projects. And we continued that, but in a virtual space. And we did it a little bit different and kind of had to do a smaller meeting size just to make sure that it was manageable. But we have been able to continue to report on those projects and move projects into the PSNE process and begin right-of-way acquisition, and all of those different things. And so speaking of virtual project status, if any of you have been in a virtual meeting in general with me, you know how the echo makes me crazy. And so that's one of those lessons learned of we need to be muted at times. We need to have our cameras on. Mark Buckaloo, that one is for you. I personally, when I meet with people, I like to be able to see their faces. Obviously, in larger meetings, it can be a little bit more challenging. But it's really important to be able to see each other and connect that way, especially if we have to be virtual. And then we've also learned about how backgrounds can be funny and they can be awful. And so don't encourage them very much, but some people have come up with some really creative ones. And we've just learned to kind of use the technology and make it work for us. So number 7, and it's a serious topic, is the fact that while we saw volumes plummet at times early on in the pandemic last year, we didn't see speeding and crashes go down at a proportionate rate. And so we were fortunate, if you will, in Delaware to have seen a decrease in fatalities year over year from 2019 to 2020. But honestly, 2019 was a very high year for us. And so the fact that we still had 113 people lose their lives on our road is a big deal. And we still have a lot of work to do in the area of safety to continue to drive those numbers down. I want to talk a little bit about virtual public involvement because that was a huge, I would say, change for us. We were used to doing some virtual public workshops where we might have posted some slides online, did a survey of people, maybe even had a video. But trying to actually engage with people virtually was truly a learning lesson. And we challenged our teams to think differently, to get outside of their comfort zones and do live Q&A on Zoom or WebEx to engage with people. We had the 5 Points Working Group continue meeting virtually. We had numerous public workshops that had to be virtual. We even, for the Route 1 and Cave Neck Road GSI, had AECOM develop this virtual meeting room, which was really cool. So you felt like you were actually in a room with staff, walking around and touring the different boards. We have been engaging more people because of this, and that's what's been interesting. More people are willing to just hop on, a virtual meeting and listen in and see what's going on versus leaving their home and maybe going to a fire hall or to a library. And so that's been an interesting learning experience for us. And I think there will still be some component of kind of these virtual public workshops moving forward. We obviously want to get in rooms face-to-face with people at some point in time, but this provides an option for more people to be engaged. They can be sitting and watching, the workshop while eating dinner and taking care of their kids and still be engaged in our projects. And so that's been a really interesting learning lesson. We also continue to deliver our biggest capital project, single capital project the department has ever delivered. So we started 95 just a couple of weeks ago with our shifting the maintenance of traffic into place and starting actual construction last week. And so when you think about the size of that project, the fact that we were delivering it in the construction manager general contractor methodology, where you had the contractor on board during design, we were still able to kind of keep all of that going. And we did that for numerous projects. And it's just kudos to the teams for being able to figure out how to do this and how to keep delivering our program. I cannot talk about any of this without talking about technology, and there's a lot to say. I think first off it's interesting to me as I reflect back, all of the things that we had done over the last, let's say 4 years, that really prepared us well to be in this crazy environment that we're in. Things like electronic plan reviews, e-signatures, e-construction. I'm echoing. And then, so all of those things that were really in place already. Very interesting that we were kind of already on that path. And so when we had to make the switch, it was easy to keep things going when it came to PS&ing projects. We also had to do things on the fly, like get everybody set up for VPN that was going to telecommute, acquiring computers and monitors. And so a huge kudos to the tech and innovation staff because they truly stepped up to the plate, and also kudos to our engineering support staff for all of the work that they had already kind of done in advance to make all of this work really well. The top 3 lesson learned is Mother Nature. Woo! We hadn't had much snow in a few years, and we thought that we were kind of in the clear. And then 2021 hit, and whoa, was it a doozy with snowstorms, sleet, freezing rain, ice storms, you name it. We really had to step up to the plate, and our M&O folks and our traffic safety folks did a great job. And it was really nonstop for many weeks. And then put on top of that, if you think back to the fall of 2020 and the tornadoes and significant rainfall events that we've had, it has been crazy, but again, we've still been able to deliver on our mission. Speaking of delivering, in fiscal year 2020, we delivered our largest capital program ever. And it's not just about the money. It's about what the money does, that it does improve transportation. It helps people get to the places that they need to go. It helps them get to opportunity. And it's just really exciting that it's taken us a while to really be able to kind of hit that mark really well. And so it was very exciting for 2020, and we are on track for 2021 to even exceed fiscal year 2020 expenditures by some. And last but not least, we have the best team ever. And not that that was a lesson that needed to be learned, but it's important to note. We were nimble. We stayed open for business when many other surrounding states had issues. We kept delivering. We took on things like food and PPE drives, protests, presidential movements, COVID testing events, and now COVID vaccine drive-throughs. We've done things that were just outside of kind of our spectrum, it seemed like, and we really stepped up to the plate and we took on every challenge with an attitude of really wanting to overcome it and to meet and exceed anyone's expectations. So another thank you for what you do, what you continue to do each and every day. And so I really hope that this Lessons Learned workshop will be an opportunity for all of us to learn from each other and to learn with each other. So with that, I'm going to switch gears to being good neighbors. With all that said, we do a lot, and what we do has impacts on people. So I know that this isn't the first time you've seen Mr. Rogers in the last few weeks. And I used to love watching this show, but as a type A personality, it always bothered me that he couldn't quite get it all done before the song ended. And so that's one thing that always sticks in my head about Mr. Rogers, but he was a great neighbor. And what did that look like? So let's talk a little bit about our mission, excellence in transportation for every trip, every mode, every dollar, and every one. And so as we talk about being good neighbors, I really want to focus on the everyone piece of that. And so what we are committed to do is engaging our customers and employees with respect and courtesy as we deliver our services. And I want you to just think about this for a moment, that our roads are everybody's neighbors. Think about that. Every road somehow touches people. And so what we do with those roads matters to people. If you think about your neighbors, whether you live in a neighborhood or even if you live on, a large, farmland, you still have neighbors at the end of the day. And those neighbors can be great neighbors or they can be happy neighbors. And we want to be good neighbors or even great neighbors. I think about my next door neighbors who are in their 80s. And when they first moved in a few years ago, that we actually did have snow that year, and it was a heavy snowstorm, and we were out shoveling our driveway, and we just went over and did theirs unbeknownst to them. And that was something that I did because I wanted to help them, and they were so gracious about it. And that's the kind of thing that we want to go kind of above and beyond for all of these people that are the neighbors of our roads. So some facts. What we do is important. Our transportation improvements are important for a variety of different reasons, whether it be safety, reducing congestion, connectivity, connecting people to different opportunities. So they're important. But when we do projects, they can have impacts, and they typically do have impacts. And so we need to be aware of that and recognize that. And we also need to try and mitigate those impacts. And we do a great job doing that in a variety of different ways, whether it be our right-of-way folks sitting down with people and talking about exactly what's going to happen as part of the project and being able to mitigate any concerns with whatever special, tree that they have planted in their yard, or, are you going to impact my septic? Or what's it going to look like when it's all done? We're taking care to do that, and our construction folks are taking care once the project is in construction. And at the end of the day, we just want to make sure that we are enhancing people's quality of life. And so I think those are the facts that I think we need to keep in mind. And so I love this saying, just because you can does not mean that you should. And so we have a lot of authority kind of bestowed to us because of what we do when it comes to right-of-way. And so the decisions that we make, as we're trying to deliver these projects, they matter. And so, yes, we have the authority to, cut down these trees because they're impacted by the grading. But if your beloved family member lived there, what would you do to mitigate that? Would you think through that process? And so would you say, yes, I have to cut these down to do this grading, but I need to make sure that they're aware of it, start there, and then what can I do to fix it, even when the trees are in the right of way? Or something like, because we had so much snow removal, we had a situation where there was, where we had basically stone across someone's driveway and snow on top of it, and this person was older and they couldn't use their snow machine to move it. And so how can we address issues like that and have some empathy for people? And so I think we just need to make sure that we're thinking about what would we want to happen to us, or what would we want to happen to, our dearest family member or friend who has a transportation project kind of coming across their frontage of their road. So to be a good neighbor, we need to listen. And I think we do a great job of that all along the way, but we can always improve and do more. But listen, because people want to be heard and they want to feel valued. And that's really important. And so taking the time to listen and understand what their real concern is, because it may not be the thing that they're telling you, is really important to take that time to do that. Communicate, and frankly, over communicate. There's so much that we're doing and we all understand it, but I don't know that the average person does. And so taking the time to make sure that we've said, here's what's going to happen, and say it in a way that they can understand it and not use all of that technical jargon. Being proactive, and it ties directly to communication, that we need to let people know what's going to take place, in the coming weeks or in the coming months, that they're aware of that. So they're not caught off guard, so that we're not doing a survey of a property and people have no idea what's going on. They don't even know there's a project there. That's especially in kind of the times that we're in, people are very anxious. And so we have to make sure that we are being proactive in communicating. Because lastly, we do want to enhance people's quality of life. We don't want to leave them after a project is complete and they feel like it's worse than it was before. And so that's super duper important. And so I just want to encourage all of us to be good neighbors, to think of Mr. Rogers, especially as we're tackling different transportation issues. And I know that our projects do have impacts on people and we can't make everybody happy, but we can listen to everybody and we can try and do something to address their concerns that they have. So with that, thank you so much and enjoy the rest of your day.
Thank you very much, Shantae. We'll strive to be good neighbors going forward. All right, so again, my name is John Curiano. I am the support engineer, and I will be presenting on some inspection observations. I want to focus on the framework again that we talked about at the winter workshop a little bit, as well as diving into some good examples and some lessons to be learned from those primary inspections. So the framework was established to be effective in March 1st of 2020, and it replaced the old semifinal and final inspections with an initial and primary. It also outlined which staff should be attending these inspections and had the goal of alleviating the multiple punch lists that were presented. Also, the final goal is really to get a faster acceptance of our projects, and we did that through the use of timeframes established in that framework. So the initial inspection was supposed to be completed by the administering section prior to the contractor demobilizing or substantial completion. The administering section will then create an initial punch list of items. They're to include E&S deficiencies, ADA inspection results, safety and bridge management list. And that list is to go to the contractor within 7 days. And the list should be an itemized list of the deficiency, the location of the deficiency, and indicating financial responsibility. This is an example here at the bottom right, just showing a general initial inspection list with the items and whether or not it was a contract item that they be paid, or if it's the responsibility of the contractor through a previously paid item. This is another example of an initial inspection punch list. This one has a few more pictures and some detail. So this is a really good example. It tells you what exactly the problem is. It talks about the deficiency specifically, and then it indicates the location with a station and an offset. They even reference the plan sheet number in this case, And again, the financial responsibility is indicated. So the administering section is also responsible for maintaining that initial list and documenting when the contractor has made the corrections to those items. So this one on top shows us the list itself with the annotation in red from the area engineer indicating that those items have been completed. They also did the same thing on an ADA inspection where they put some notes as to how they addressed some of the ADA deficiencies and indicated when that work was corrected so that they could go and schedule the primary inspection. So the primary inspection, again, is scheduled once all those initial lists are addressed, those items on the list are addressed, and you'll coordinate with engineering support to schedule that date, and then you'll invite those other groups that are listed on there. You'll meet on site, walk the project, review it, identify additional items that might still be outstanding, discuss the list at the end of that meeting, and then the administering section will create a primary punch list and send it out within 7 days to those that were there attending the inspection for review, and then in 14 days it goes to the contractor. So here's just another example of that primary list, telling to grade at a maximum of 6:1, apply topsoil, seed, and blanket at a minimum of 2 feet behind the sidewalk. Again, it gives you the station count, so it's easily identifiable where that is, and it indicates that it's the contractor's expense. So engineering support attends the primary inspection, and they're there to be a resource for people, identifying specs and details, the contract requirements, and they end up generating, or we end up generating our own reports for departmental documentation, for education, and for best practice development. So we put these reports out there identifying, things we saw on those inspections and citing specs and details where those requirements are found in a means to educate people going forward. So again, you point out the specs and details. That's just a sample of what the report looks like at the bottom. So we have monthly inspection meetings after we put all these reports out. Right now we're averaging around, I'd say 12 to 14 reports a month. So we'll put this list out and invite the area engineers to attend, and we talk through some of these projects and what we saw on those inspections. So Jansen will go through and identify a few things that he'd like to bring up for discussion to highlight. And then those people that are present are free to discuss those items. They can bring up items that they choose to. It's mainly to exchange ideas and make sure we're doing things correctly, and identify any areas that we might need to make improvements on, whether or not we have to make an improvement to a spec and detail or a process, that could come from these sort of meetings. Then I will send out a monthly inspection report after those meetings where I try to highlight specific areas for attention going forward, because not everybody attends these meetings. I try to break it into, construction, design, ADA, bridge, or traffic items to try to point out to those groups that aren't present, some things to consider as they design projects going forward. Okay, acceptance. So once all the primary punch list items are completed, the administering section will notify the district engineer and the maintenance engineer that all the primary list is addressed. They will, annotate that list at the bottom there and send a recommendation for acceptance letter, which is shown on the right. Then maintenance will verify those items within 30 days and then accept the projects. So that's an outline of how the framework is supposed to work. So where are we now? It's been about a year that this framework's been in place. I think it was March 1st, I said. So we're in the process of evaluating some of the data that applies to the time frame for this framework. We also are obtaining observational feedback from some of the users to see what's working, what's not, what needs some tweaking. And then we will collaborate with others to make the necessary changes and update the specifications accordingly. So these are just some of the data points that we're looking at going forward. A lot of it's tied to those timeframes that I talked about. the number of days between the primary punch list for review to the inspection team and so forth, the number of days between the primary punch list completion to the signed acceptance and things like that. So these are just some of the items that we're investigating. So I did an informal poll of some construction, maintenance, engineering support, and BCA members to see how we're doing with this framework. I asked a few basic questions. One was, what are the biggest challenges you see with the framework? Some of the challenges included getting the initial inspection prior to that substantial completion. It's hard to have that inspection if not all the work's completed. And then the time frame to get the initial list out is hard to meet because the initial lists are going to be a little bit longer now. Also, there's someone expressed that they're not getting a list of items for those that for those that can't attend the primary inspection. They're not receiving that list ahead of that inspection. And then also the terminology still seems to be an issue because it doesn't match the contract documents. Other challenges are just getting the inspection scheduled and completed in a timely manner and include all the parties that are necessary. All right, so what works well? That was something that people had outlined or said that the framework adequately outlines the process and it makes it clear and provides consistency for all involved. When it's early and all parties are represented, it's a lot more efficient. And scheduling the primary doesn't take as long as it once did. And somebody also mentioned that they like the annotation of the checklist. So there was also an expression that the designer and engineer of record should attend the initial inspection because there's some things that can be worked out then. And sorry, I just lost it. Also, ENS and safety is to be invited to those and outline the time frame for the contractor to address the initial punch list. These were some DCA comments. They wanted to decrease the time frames to get the official punch list from initial inspection back faster. And they also thought that the ADA inspection should be held before the initial. Some overall comments, people seem to like the new framework. They just think we need to go back to the traditional naming convention. Construction has been sending some photos with the repairs that have been made. That's a huge help to maintenance on the follow-up. It allows them to, see a photo documentation that things have been resolved. So that was just some feedback. Again, in the near future, we're going to be looking into the data a little bit more and going through those comments more individually. I just wanted to give you some snippets of what people had said on that informal poll. So now I just wanted to talk about some of the things that engineering support sees on our primary inspections, some lesson learned, some good examples going forward. So I realize there might be a perception that an engineering support comes out here to tell you what you're doing wrong, but that's really not the case. We're here to, not be the police or not internal affairs. We're here to educate people and make sure we're getting the quality in the product that we desire. Does it match the contract documents? We follow the specs and details. Is it actually a safe installation for the traveling public? So that's really the goal here, and we want to foster a dialogue. We'll ask you questions as to what was done on the project, and we can only really see what's on top. So we're going to ask you what happened underneath. So we're here to help. We're not trying to point fingers. We're just trying to get the best out of the best product that's possible. So here's an example of some good pavement down near Northeast Front Street. Nice paving project. Got rumble strips and nice striping. I just want to talk about some items here going forward. Open joints, we've seen a couple of these along the edges of road or tie-ins or at butt joints. We're not sealing those. This could allow for water intrusion to happen. The picture on the left is a good example of a butt joint seal. You know, if that water gets in there, it could cause premature deterioration of the roadway. Again, some sealing, the patchwork should have a seal around it. The manholes in those pictures and junction well, I mean, those all have good seal. And there's a nice seal in the upper picture there where there was patchwork done along the curb and sidewalk. So we've seen some sumps on some of these projects. You can see in the photo there's some depressions, the ones even holding water. So we'll ask the question, you know, what's going on here? Is there a compaction issue? There's a tolerance in the specifications that you can only have a quarter inch deviation in both the longitudinal and transverse direction in 10 feet, and that should be corrected. So those are some of the things we'll ask about. Pop outs, we want to fix those. Sometimes there's a bonding issue and the aggregate will separate and pop out. And this could prevent a more premature deterioration of the pavement. Also, there might be an adhesion problem and we might get shoving of the pavement. Utility lids and manholes covered with material. We want to make sure that these are accessible at a later time. So can we get in that manhole if it's covered with hot mix? Or can the utility company get in there? I mean, the bottom picture is a good picture of, you know, a seal around that utility. However, it's kind of covered in concrete, so it's going to be challenging for them to get to at a later time. Rumble strips. This is more so, you know, project scoping and design. I brought this up because, you know, you want to make sure that you know what's going on just outside your project limits. You know, did they exist prior to the project? Does my project, you know, cut off a section of rumble strips that did previously exist? You want to include those items and, you know, details for that. Also, you know, we realize that project development takes several years. So when you go out to PSE, you might want to double check the site conditions to make sure that there hasn't been a project come through to put in rumble strips. The same thing with raised pavement markers. Make sure we include those items. Make sure they have the right lens colors and orientation. You know, between two lanes going in the same direction, they'll have the white color, but down the center line, you'll have the yellow. And then obviously this installation here on the left, there's a little bit of epoxy covering the lens, which makes it difficult for the traveling public to see the lens. So it's losing its effectiveness. Signs, everybody's favorite. I kind of left this in for Jim Pappas because he loves hearing about the sign sleeve height. But yeah, it's not supposed to be more than 4 inches. I'm not going to stick on that too long. And if you have the double sign blades, I think it's with the sign that's got the 6-inch height and lettering, you should have that pin assembly that's shown on the right there between the signs. Vegetative stabilization. You know, obviously we want some nice grass and nice vegetation along our roadways. I mean, this kind of looks better than my yard, to be honest with you. The picture's on the right. We want to backfill any settlement or rills or washouts, and then stabilize the area with, you know, vegetation, maybe a blanket mulch. You want adequate vegetation coverage. That final stabilization is complete vegetative growth, consisting of perennial grass reaching a height of 3 inches and 70% uniform density over all the area. So the pictures on the bottom, obviously, I think we need a little bit more work on those, but the picture on the top is a pretty good example of, you know, vegetation and the blanket mulch coverage in a swale area. Blanket mulch must be identified on the approved product list. You don't want to be using the photodegradable products. It should be the biodegradable. You don't want that plastic netting in there. And it should be adhered to the surface so you don't get erosion happening underneath that blanket mulch. All right, so we have a lot of structures out there, sign structures, light bases. We should only have the top of those bases 4 inches above grade, so we'll have to grade around some of those to make sure we achieve that. Also for utility valves, junction wells, and other appurtenances, you want to do the same. You want to grade those flush. You know, sometimes we have a mower, maintenance mowing operation going through there, and those could stick up and hit a mowing deck pretty severely. All right, so some other vegetative items. We should be keying in and securing geotextile under riprap at the ends of pipes. This is like your energy dissipators or you just riprap sections there. We could potentially have some undermining if we don't. We've seen some instances where they just have the, rock, the riprap just sitting on top and holding it in place. It should follow the detail there on the right where you secure it with a pin and then cover it with soil on top of it for at least 6 inches. And obviously, I think we should remove any sediment or vegetative buildup that is present and impedes flow within our drainage network. If you're seeing like a tree grow out of the end of a pipe, I think you might want to consider removing that, just to make sure it's going to operate as designed. For our pipes, we recommend that the lift holes be arched, so you should be filling those in to prevent any sediment or water to pass through. Same thing with the ends of pipes when you cut them off. Some exposed repar, we recommend that those should be parched as well to prevent deterioration. Also the safety grates, they should have their locks up on the top right. You can see that's missing. Pipes, when they enter the drainage inlets, are to be mortared and flush with the wall. It's use a non-shrink grout between the pipe and the wall, the DI. So steps should be provided in drainage inlets that have a top slab or are greater than 4 feet in depth from the top to the lowest invert of the invert of the lowest pipe. And those steps are to be no more than 2 feet from the top of grade, the first step, and the bottom has to be 1 foot max from the lowest invert. And the steps basically go into the wall of the box 3 inches and stick out 6 inches. Typically, they're found in the back wall of the inlet, but I think we've made exceptions because of the pipe orientation. Flow channels, our inlets should have flow channels to maintain positive drainage. When we come across a location that has some standing water in an inlet, we'll question whether or not the flow channel's in there. The details there to show that you just want to warp it and allow for that drainage to be conveyed through the other pipes. Some other items we've seen on drainage inlets, we've seen formwork and foam remaining within the structures. We've seen some honeycombing around pipe entry. Might need to parch those areas. Also, broken grate in that one picture, but the picture on the right at the top, maybe we could consider a different grate type. I think that's a type 2 grate. I think there's a shared use path adjacent to that. However, there could be bicyclists using that, and you might want to consider a different grade type. If somebody's riding a bike down the shoulder, a more serious cyclist. Just things to consider. Great orientation. So if I had an audience, I'd ask you which one is not correct for a sump condition. It's actually going to be the one on the right. So the orientation should be pulling the water from the flow line into the structure at a diagonal. The one on the right is actually going to force water to bypass the opening a little bit, so it won't be as effective. So those are all in the standard details. It's a good example of some PCC curb and sidewalk. This is the Christina River Bridge. Some considerations for PCC curbs. I was focusing a little bit on design here regarding the gutter flow and drainage. We've seen some times where we just saw curb lines without the gutter, and it, had some issues with conveying water down the curb line to the outfall. So when possible, I'd advise to use gutters. Verify the outfall within the project scoping. A lot of times we tie into a certain location, but there could be a high point just beyond that location. We've seen that where, you think you're matching existing, but right beyond existing, there's a higher point that causes the water to back up within your proposed improvements. So don't just limit yourself to the project area, go a little beyond to make sure that your water can drain properly. Does the typical section prevent roadway from draining? Is there adjacent grading that's built up at the end of your curb run, kind of like the picture on the right, that prevents that water from getting to the drainage inlet? Are you in a cut section that you have to be more, that you have to shave more of that back in order to get the water to leave the roadway? We've also seen some instances where we have some conflicting notes where you want to ensure positive drainage and match existing pavement or curb elevations. This kind of makes it hard for the contractor to really figure out what you wanted them to do. So make sure we're clear when we're using notes like that, that we don't have contradictory information. Also, entrances of driveways may require some other consideration. You might need to throw some additional grades out there if you're trying to maintain the drainage pattern through the driveway, or look at some upstream drainage structures to catch your spread. And the same thing with pedestrian connections. This has been an issue that we've been seeing more and more. Make some consideration for a drainage structure upstream, because pedestrian connections, a very low lying area that's level. You're thinking about your spread, your curb basically goes away on the back wall, and it allows your spread to enter into the pedestrian connection, causing some ponding issues. So when you're designing a pedestrian connection, look at what it's doing just upstream and see if we can put a structure in to minimize the spread going through that location. All right, so sidewalk and curbs. We want to seal any uncontrolled cracks in the concrete, as well as make sure we cut joints at our 10-foot intervals. There's also the detail to provide a 2-foot at 6:1 grading adjacent to the sidewalk or shared use path. We've also heard from the contractor that, the hinge point causes some problems when you have a 6:1 for 2 feet and then down at 4:1. So when right-of-way does permit, consider carrying a 6:1 all the way down. I know right-of-way can be, tight in some spots, so that's not always feasible, but apparently the hinge point had caused some issues with some contractors. So islands, these should be depressed on the leading noses. Obviously everybody thinks about the snow plow that could be driving through there and clip that nose, cause a pretty jarring incident then. So the picture on the left is a vertical curb, should probably be depressed. The plans had specified a vertical curb though. It's also missing the tubular markers or delineators on the corners. The one in the middle has those markers and it's depressed. And the one on the right side is a median island. The picture of that one I wanted to talk about was specifically regarding the sign placement. For the detail, it should be 10 feet from the nose of that island so that a turning vehicle doesn't clip that. All right, bridge beams. Painted bridge beams should be, they should have the bridge number on it and when the painting occurred, and that should be on the outside of each fascia beam on the approaching traffic end of the structure. So that's a good example of that bridge number and the April 2020 date that was painted. Some guardrail items. We've seen some loose hardware, also some excessively long bolts that we could cut off. Some offset block orientations, were kind of skewed. Also, the bearing plate should meet the requirements and the details. It should be vertical, it should be rotated, it should have the cable to hold it in place. Any holes that are in that maintenance paving should be filled. Even those holes in the back wall, the barrier connection should be filled to prevent deterioration of that structure. So some other thoughts, end treatment grading. I think Adam's going to get into guardrail a little bit later, but from a design standpoint, I just thought we should ensure that we have adequate right-of-way for that grading. I think we run into some projects where we have to upgrade and we don't have the right-of-way up front. So we don't provide for that grading. So if we have a little bit more forethought to consider that, that would be helpful. Also, how does that affect the proposed drainage? I think I was the designer one time and I ran into a situation where I, I'll put it per the detail, but I didn't think about what the drainage swale was doing behind that. So if I actually built out that grading that was necessary, what does it do to my swale that I had there? Do I have to pipe that area? So think about that. Delineator panels, these are to be on the end treatments. The picture on the right is for two directional traffic on a divided highway. So that should actually have the left shoulder delineator panel that's shown on the left. For traffic going in the same direction at a gore area, it would follow more of the chevron for medians. And then for the right shoulder, obviously the right shoulder delineator. Oops. So some other guardrail thoughts. Make sure we consider the offset in the clearance distance behind the barrier. For a type 131, it's 4 feet. But we have a picture here in the middle with the tree on the right side that if that guardrail struck, it's going to deflect a little bit and into that solid object. So when we're laying out guardrail on our plans, make sure we provide for enough distance to allow for the post rotation and deflection so it wouldn't hit that object. Curb openings are another thing. We've indicated a lot more curb openings along these curb sections under the guardrail, and they're coming into conflict with the post spacing. So one of the ways around that, or to deal with that, is to use leave outs. And that's the picture on the top. It shows a leave out installation. It's a really good installation. It follows the roadside design guide where they use it's a low PSI grout or like a hot mix or maintenance paving material around that, so it allows that post to rotate. And you can place it within the middle of your curb opening. You don't want it to be fixed in concrete because then it won't rotate properly or perform properly. Also, we have a detail with a guardrail with omitted post. So you actually don't have that one post in the area of where the curb opening would be. So when you're doing that, what happened there? So when you're doing that omitted post detail, you want to work from the end treatment back and look at your spacing, and then you can figure out where my first curb opening can be going forward. We've also had some projects where we were just doing overlays, and it wasn't in the scope of the contract to worry about the guardrail. So what ended up happening was we significantly reduced the height of the guardrail, so it's not going to function properly. So when you're doing these overlay projects near guardrail, consider maybe doing a profile milling, or see what you have to do to make sure we can maintain the 31-inch guardrail in these sections. This also produced a little bit of a lip or a drop off, so you don't have that 10-to-1, grading that we had in the standard details for the guardrail. So again, profile mill when possible. So this is a good example of some contrast pavement markings on the concrete on the left side. I think this was up on, I think it was Carr and Marsh. And the picture on the right is a good example of having the signing and striping work out together. The lane ends there and the stripe is right next to it. So that's a nice installation. So some considerations. Consider what the proposed improvements will do to the existing striping. The picture on the left was a signalized intersection at one time. It was changed to a stop control, and it resulted in a staggered stop bar. So now there's a stop sign, and the vehicle in the left lane can't see because the vehicle in the right lane is a little bit further out. So, just because we patched that one area, look a little bit beyond that to see what sort of impacts you have on the other striping in the area. That vehicle now in the left lane is going to have a very hard time coming out and having adequate sight distance. The picture on the right, we're patching a sidewalk, or a curb along a sidewalk, and we've cut off part of the bike symbol. So, just consider what your proposed improvements might have on some of those other striping items that are out there. We want to be putting asphalt sealer or the blackout paint on the striping removal, and then make sure we're having the right size symbols. Or thanks, Bob. I got the 5-minute warning. The right size symbols from the MUTCD for striping. We've also seen some traffic electric service pedestals that are missing the cross member. There's a lot of equipment that's on these panels, and it has a cross brace member to keep it sturdy, with the wind loads and everything else. Also, we've seen it where it's not meeting the 4-inch requirement for the sign sleeves. I think that's a traffic contractor that does that, but if you're seeing that on the construction site, you may want to reach out to them and say, hey, you're missing the cross member. All right, vertical differences. If it's greater than 1/4 inch, it has to be addressed. We have some sidewalks here that have that little lip there. That's going to be challenging for somebody to traverse normally, let alone if they're in a wheelchair. We also see that expansion material that remains sometimes that could easily just be cut off that would resolve that issue. And up there in the top right, we see some times where the paving has been placed a little bit higher than the pedestrian connection. It results in that lip that prevents somebody from traversing through the intersection. And then, unfortunately, in situations like the bottom right, we have a crosswalk that goes into a vertical curb. So that's obviously going to be that obstruction. So this is an example of a cluster mailbox within a subdivision. We don't get into these too much, but I thought it was a good example to demonstrate some consideration for accessibility and turning space. You got to think about the accessibility of somebody getting to that mailbox, let alone accessing their mail, turning and going back, to their house. So we got to make sure we have that turning space, the 5x5 for new projects and 4x4 for restoration type of projects. So not just mailbox installations, but turning space when you're having two intersecting pedestrian connections, with that go in different directions. So where you have two that meet and go different directions, you need to have a turning space. Also, protrusions and vertical clearance. We see a lot of branches that overhang our sidewalks. There's also utilities that stick into our PARs, our sidewalks. And when you're scoping this, you should, consider, is there a way to maintain a PAR and leave the utility in place, or do I have to do something to delineate that utility? If it's overhanging into the PAR more than 4 inches and between the, I think it's 27 to 80 inches, if it's in that area, you'll need to delineate it somehow. You can use a vertical curb, you can use delineators like a tubular marker, so that if somebody's visually impaired, they can detect that there's something protruding into their walkway. Trim the vegetation, try to avoid utilities within the PAR, and then when you're placing your signs, try to make sure they're outside of the PAR when possible as well. DWS, or detectable warning surface, these should extend the full width of the curb ramp, or they shall extend the full width of the curb ramp and the fully depressed curb. And then this last one's kind of new. We developed a new directional tactile surface indicator. It's a longitudinal DWS, essentially. It's located on the approach and exit of bike ramps. So when you have a pedestrian route and there's a separate bike route that enters or exits, we use this to indicate to somebody that's visually impaired that the pedestrian path keeps going forward, but a bicyclist may depart from that or enter into the pedestrian network that way. You didn't want to just use the traditional DWS because it would direct a visually impaired person into that facility, or in this case on the right into the roadway that's adjacent to the bike lane. That's pretty much it. So, I mean, lastly, I just wanted to stress communication. I think Shantae hit on it well. I realize we're all trying to close out our projects faster. And I think communication is just key to exchanging ideas and, improving processes that may need improving. So I thank you for your time. And with that, I will turn it over to Adam Weiser, who's now going to be presenting on the maintenance of traffic design and implementation.
Good afternoon, everybody. Again, my name is Adam Weiser. For those of you who don't know me, I'm going to be talking today about temporary traffic control and maintenance of traffic, focusing on design and construction aspects related to lessons learned, and also get into some of the cooler things that we're doing with smart work zones as well within the safety section. So I want to thank Mark Buckaloo and Jeff Van Horn for giving me the opportunity today, and I'll use air quotes for that, for presenting in their places today. So let's see. There we go. So I'm going to touch on just work zone crashes in Delaware, just giving everybody an update on where we stand with work safety in our work zones and how that kind of compares to just overall crashes in the state over the last several years. There's been a lot of changes over the past couple of years related to the safety program section and the staff and responsibilities in that section. So I'm going to go over that a little bit just to get everybody on the same page of who's responsible for what and who you need to contact in different situations. And then I'll jump into some design and inspection considerations related to temporary traffic control, maintenance of traffic. Quick update on MASH, again, related to temporary traffic control. I'll have more on MASH related to guardrail in my next presentation later this afternoon. Talk about the approved products list, and then I'm going to touch on smart work zones. We've looked at, recently looked at the statewide crash statistics for work zones as well as the entire state. As you know, we just completed the strategic highway safety plan, which is available at safety.deldot.gov if you want to take a review of that. But one thing we did for the safety section recently is look at work zone crashes statewide, basically from 2015 through almost all of 2020, was through December 7th of 2020. And you can see that less than 1% of all crashes statewide occur in work zones. One thing to note here is this is underreported. There are quite a few crashes that are occurring in work zones that don't necessarily get coded as a work zone crash. And when we look at that within the CARS program, we look for specifically those crashes that are coded as work zone crashes. So that's something that's been in the works with state police and other law enforcement agencies over the last several years of trying to get better reporting. And we've seen improvements, but there's still those outliers that exist. When you read the narrative, it says this crash occurred in a work zone, but they forgot to check the box. But again, less than 1% of all crashes occur in work zones, which is good. We want to keep those numbers down as much as possible. We looked at all different crash severities. We looked at property damage only, injury, fatal crashes. So overall, within over the last 5+ years, over 1,200 work zone crashes, 8 fatalities, 22 serious injuries, 229 minor injuries, and 155 possible injuries. And the majority of these crashes are really property damage only crashes, no injuries involved to any people or workers. We do not know, unfortunately, easily with how many workers were injured in work zone crashes. That there's no fancy checkbox on the crash report to indicate whether a worker was injured. We do know if workers were present in different situations, but we just don't know if a worker was injured without physically reading the narrative and looking at who was involved in the crash and who was struck. So we would need more information on that to determine how many workers were actually injured. One thing we did look at recently was work zone crashes by time of day. And one interesting thing here, if you look at the heat chart at the top of the slide, there's a lot of red in the red, dark red, light red, in the dark orange in that 9 a.m. to 3 p.m. time frame, or the 8 a.m. to 4 p.m. time frame when a lot of folks are requesting lane closures. you can see that's when a lot of our crashes are occurring. And granted, that's when a lot of, we do have a lot of traffic volume on the roadways as well. But this does look at the time of day related to nighttime crashes and how that impacts our work zones. And we see a lot less crashes overnight. So that's one reason we look, besides traffic volumes, we also look at the safety of doing nighttime lane closures, and this helps justify that as well as the traffic volume impacts do as well. So just some trends, 85% of work zone crashes occurred in Newcastle County. Probably makes sense since we have quite a lot of work going on in Newcastle County. 78% resulted in property damage only, so no injuries to any vehicle occupants or workers or anything of that nature. We looked at where the crashes are occurring within the work zone. So you have the advanced warning area, you have your buffer space, your activity areas, and your termination areas. 68% of the work zone crashes actually occurred within the activity area of the work zone. And we did a recent process review for FHWA, and this is really what we focused on, is where our crashes are occurring in the work zones and what can we do to make improvements to reduce that. One of the recommendations was looking at things to potentially shield the view of the work activity going on from the motorists, so they're not distracted. So that's one thing that was recommended out of that study. 62% of work zone crashes occurred May through October. Makes sense, prime construction season. 49% were rear end crashes, and what this tells us is a lot of the crashes that we're seeing in work zones are congestion related, or related to folks that are slowing for a merge, a lane closure, those types of things. 42% occurred within a work zone that had a lane closure. 36%, we talked about this previously, occurred weekdays between 9 and 3. 11% of single vehicle crashes involved a vehicle striking work zone or maintenance of maintenance equipment. Some of those include vehicles striking TMAs out in the work zones. We looked at, was there any factors related to heavy vehicles? 9% of the vehicles involved in a work zone crash were tractor trailers. And then 1% were of people involved in work zone crashes were fatally or seriously injured. So, while that number is low, we want that to be 0. So that's something that, definitely needs to be addressed as we continue to move forward with work zone safety. So for safety section staff and responsibilities, I wanted to just kind of highlight this for Jeff and his staff to, so everybody understands what the responsibilities of that group is, and who to contact. So Jeff Van Horn is the safety programs manager, and he manages the group that includes special events, hauling permits, which used to be in DMV. When I was in the section, we acquired hauling permits out of DMV, I think 2015 or 2016. Highway safety programs, which is Lay and David, they're responsible for the engineering side of temporary traffic control and such. And then the safety officers, which are folks in the field inspecting and reviewing the work zones. From a contact standpoint, I'm going to start on the right side of the slide. So Jeff is obviously the section manager and statewide contact. Jerry Nagiski is still the chief safety officer, again, statewide focusing. And also Catherine Weissop is now a statewide safety officer, and she's going throughout various work zones across the state doing inspections, helping out the district safety officers with their work zone inspections. So you'll see her out in the field as well. One of the newer additions to she's been in safety for a few years. She was actually previously in the hauling permits group and has moved over to the safety officer group. On the engineering side, Lei Zhu and David Wynn are both the engineering contacts. So if your projects are in North and Central District, you want to reach out to Lei. She would be your point of contact mainly on the design side for TMPs, transportation management plans, detours, coordinating plan reviews, those types of things. And then David Wynn is going to be handling Canal and South District projects. So he'd be the point of contact again for TMPs, detours, et cetera, for Canal and South District project locations. And then the safety officers, Jimmy Moust is the newest addition. He covers North District. Martin Lord, who's been there for a number of years now, covers Canal District. Bobby Johnson covers Central, and Dan Thompson is still South District Safety Officer. So take a screenshot of this if you want, or this I guess will be available on the web. There's all their contact information there if you need to get a hold of them. Okay. So we'll jump into some of the design considerations, and I'm going to focus kind of on general items at first, and then we'll get into some of the details related to the MOT plans. So for general items, some plan review items that I wanted to note. One thing, and this isn't on every project, this is some things that the safety section has asked me to kind of bring up as part of this presentation. Plan review comments not being addressed. And there's been situations where for various reasons, between the formal department-wide reviews, between preliminary and semifinal or semifinal and final, that comments aren't being addressed for various reasons, or they're not getting the responses of those comments that have been addressed, and you know, maybe why certain things haven't been addressed. So make sure that when you're submitting the plans, that they're getting the comment, somebody's getting the comment responses, so that the safety section can review those, especially for the ones that the engineer of record doesn't, feels that there's a reason not to address it. The safety section would like to know why, and make sure that everybody's on the same page. Also, there's been some times where safety's been asked to do a interim review somewhere between the different formal submissions, especially when safety's input's being asked for. We've taken, and I've been involved in a lot of the plan reviews over the last year and a half. We've been asked to review these plans in the interim and provide some input, and then we do provide those comments, and then those comments don't get addressed. Again, few and far between, but something we wanted to point out here. Just keep that in mind. If there's a reason that certain things don't get addressed, just let the safety section know of why that is. Major changes in phasing during design. If for some reason you're in preliminary, you have a set of phasing plans, or you phase the project in a specific way, it's been reviewed, agreed upon, and then for some reason we get semifinal plans and the phasing changes, coordinate with safety ahead of time so they know that that's coming, especially with the need to set up phasing meetings with construction and utilities and other partners. I want to make sure that those major changes don't cause other issues for the project, especially when the project gets into construction. I want to make sure everybody's on the same page with that. So if you're making major changes to your phasing, coordinate with the safety section ahead of time. And in that same regard, to help and minimize the back and forth on commenting, and I've said this when I was at the department as well, reach out early and often. Lay and David and the safety officers, and Jerry and Jeff, they're there to help you and provide guidance for, things that they know will work in the field and things that they know will not work in the field. They can help provide that guidance and, minimize that back and forth commenting at the formal submissions, especially when we get to the crunch time and you're trying to get to PS&E. You want to make sure that, you're reaching out early so we can get those issues addressed. Detour plans. So detour plans are reviewed separately from your maintenance and traffic plans. So you submit semifinal plans. The safety section will review your construction phasing MOT plans, and you usually get a comment from David or Lay to submit your detour plans separately to one of them, so that they can go into the review process for detour plans. There is a separate review process. A lot of that has to do with timeliness of getting signatures on the detour plans as well. So submit your detour plans either to David or Lay, depending on which district your project is within, at semifinal for review. They will do a cursory review, make sure that the plans meet current plan standards as far as detours go, and then give you comments back. And then when you're ready for signature, which is typically at final plans, submit them back to David and Lay separately from your MOT submission, and they will work with Jerry and Jeff to get the appropriate signatures. If you have an in-house project that needs a detour developed, reach out early to David and Lay, specifically prior to semifinal, so they can start preparing your detour plans. Looking at lane closure restrictions, One thing we see a lot of, you'll get one lane closure matrix, but your project has 4 or 5 different roadways within it. Want to make sure that your lane closure matrices, your allowable lane closure hours, you provide something for each roadway that's going to be impacted by the project. So you'll generally see a comment from safety related to that. If it's the same lane closure matrix that's on the plans that applies to every roadway, note that on the matrix. Make sure that you also specify what type of lanes that the matrix applies to. Is it for travel lanes? Is it for turn lanes? Is it related to road closures? You may need, in certain situations, 3 or 4 different lane closure matrices to identify your allowable lane closure or road closure or turn lane hours. So make sure that's noted in your plans. On the right side of the slide are a couple good examples of some lane closure matrices. The one at the bottom specifies, really well as far as how many lanes can be closed. This is for I-95. That one tells you, the contractor when they can close 1 lane, 2 lanes, 3 lanes, depending on, the time of day and the day of week, that information's on there. So, make sure you're noting that in your plans, being as specific as possible so that when the contractors are getting your plans, they understand the requirements. If you have road closures that are going to occur at a specific time of the year or require a specific duration, those types of things, make sure you provide notes for those on your MOT notes sheet. Make sure that's clearly specified. The road user costs that you've calculated, don't include those in the plans. Those go in your general notices in the bid book that the contractor will see, but you don't need to put the road user cost values in the plans. TMPs or transportation management plans. There's been a process change within safety that Jeff asked me to relay. So when you're submitting your preliminary plans, you need to request a TMP determination from the safety section. That request will go to David or Lay and Jeff Van Horn. David, you go to David or Lay, depending on which district your project is within. The draft TMP should be submitted at semifinal for review. Your final TMP for signature is submitted at final or just prior to PS&E. When you develop your TMP, especially if it's for a larger project with a lot of additional stuff that the contractor is going to have to do to mitigate traffic, make sure that any TMP requirements that are on the fall of the contractor are included in your MOT plans. So that's if the contractor is providing message boards for regional diversion routes or other types of devices, or having to do, let's say they have to pave a detour route in advance of closing the road and putting traffic on a detour route. Make sure all that is noted in your plans because generally the TMP document is not part of the bid documents. So the contractor won't see that unless it's in the plans. So make sure all that information is included in your plans and your estimates, and you've got the cost covered in your project for that. Quick reminder on the lane closure hour restriction checklist. This is required for all projects per the policy implement that was put into place a few years ago, recently updated last year. That checklist needs to be signed prior to PS&E. We want to make sure that the purpose of that checklist is to make sure that everybody's thought about the lane closure restrictions and how they're going to impact the project and the area, and make sure we're being good neighbors, as Shantae mentioned earlier. And make sure that community relations, the construction folks, project development folks, and safety are all on the same page as far as those requirements go. So start that coordination early. Make sure we get that checklist signed prior to PS&E. Road user costs. Generally, these have lately been required for all lane closures and or detours, and this has been a preference of Mark Bucklew in construction, that they have I'll call it a hammer or some type of leverage to make sure that the contractor is adhering to the lane closure restrictions. So make sure that you're coordinating the safety on calculating those road user costs. If you're doing daily lane closures, so where your lane closure is tied to an 8 p.m. to 5 a.m. time frame, Sunday through Thursday, those lane closures should be calculated based on a late opening of the lane. and they should be based on a 15-minute cost basis. Sometimes we see, a daily lane closure cost, so it's per day, but it really should be based on every 15 minutes. If you have a static lane closure, your road user cost is going to be calculated for a late opening based on your duration of your phase or whatever other milestone is determined, and that's going to be a daily cost basis. So you'll have a per day cost on that road user cost for a static lane closure, or permanent, what I would call permanent lane closure. Detour road user cost would be calculated roughly in the same way. If you have nightly detours, it's going to be a per 15-minute cost basis. If you have a detour for a longer duration, let's say 30 days, the roadway's got to be open within that sometime within that 30-day period. Those costs will be calculated on a daily basis. The calculated cost should be reviewed with the designer, safety, construction, and contract administration. Make sure everybody, make sure everybody has reviewed the cost calculations and are in agreement. And then the road user costs are going to be noted in the general notices for bidding purposes. And I put a couple examples of what that looks like on the slide there. If there's any questions on road user costs or anything like that, contact the safety section. They can work you through the process. All right, so for getting into the plan specific issues, one thing just wanted to note is, please label all your roadways, provide the stationing, north arrows, et cetera. If safety doesn't see that, you'll definitely get comments on those things. MOT notes, make sure we're using the current pay items. We're still seeing projects that have the pay items from the 2001 spec. So, make sure that you're using the current pay items within those notes. Most of those notes should be updated in the approved MOT notes that are available on the DRC. So make sure, we're using those as a starting point. Definitely should not be seeing the term traffic control manual. We want to see Delaware DE MUTCD in those notes. If you're going to use traffic officers on your projects, make sure you're using the approved MOT notes related to traffic officers. There's some notes in there that specify when traffic officers are going to be used at different times within your project. So use those notes or provide project-specific ones if those notes don't apply. On your permanent warning sign plans, so this is your advanced warning signs that go up at the beginning of the project. A few years back, we started shying away from the full complement of roadwork 1500, roadwork 1000, roadwork 500. And rather than doing that, just going with a roadwork ahead sign and an end roadwork sign. And that way, that minimizes the conflict of having all these other signs for when you do a lane closure or a lane shift overlapping all these roadwork signs. So first of all, make sure your roadwork ahead signs are placed far enough out where they're not going to conflict with your daily MOT signage. Make sure that you're providing begin and end higher fine zone signage on your projects. And if you're doing signs on a divided highway, make sure you're showing the double posts symbols on your plans. The safety section knows that those are going to be double posted. We want those signs double posted in the median, assuming there's room, and on the right side of the roadway. If there's no room in the median, then it would just be one symbol. On your phasing plans, we want to look at, for pavement markings, we want to make sure that any of the striping that's going to be placed or removed is clearly noted on the plans. There are some inconsistencies when we look at from one plan set to the other as far as which striping is going to be removed or placed in a temporary situation. Make sure that where your temporary striping ties into your existing striping, you have a label that states as such, tie into existing markings. Make sure we're showing that existing striping so we can see how that all ties in. The goal is to make sure that the striping makes sense from a road user standpoint and that, it's providing a clear path for the road user. If you have projects that are greater than 30 days or durations of phases that are greater than 30 days, considering using the permanent striping items, but in a temporary fashion. So in your striping legend or in your striping schedule, you would have epoxy or thermoplastic markings instead of temporary paint in those situations. And the goal there is to minimize the need for the contractor to go out and repaint the lines every 2 weeks. It will save the department money. It keeps the contractor safe as far as not having to put additional crews out on the roadway to maintain those markings. So keep that in mind. If there's any questions or need additional guidance on that, contact the safety section. They can help out with that. I believe Jeff, we had talked about it internally. I believe Jeff may be working with engineering support to probably try to get some additional pay items for those. I'm not 100% sure on that, but I think that email went out. I'm looking at John. He's kind of nodding his head. So on your temporary barrier, if you're using temporary barrier to protect your work zone, make sure you're providing the length of need calculations for safety's review. Make sure you're noting on the plan where the area is behind the barrier, that the contractor is not allowed to store equipment or materials, generally within that runout area. We want to make sure that that area is kept clear of obstructions. That may mean you would need to extend your barrier to accommodate that, or use TMAs or additional protection, depending on the situation. Make sure we're looking at pinned versus unpinned barrier. Again, generally, we're looking for 4 to 5 feet of deflection area from on the back work zone side of the barrier, being clear of obstructions, being clear of workers. That's for their protection. We want to make sure that in those situations, if you can't achieve that, then we would be looking at pinned barrier. Or if there's a reason why we don't want to use pin barrier, we can't use pin barrier, work with the safety section on those, and we'll work that out. Barrier offsets, I see this in the field just driving, through some of the work zones, but make sure we're depicting barrier offsets on the plans. We're required to have a 1 foot offset from the lane line to the traffic side of the barrier. We don't necessarily want that barrier up on top of the lane line or within the travel lane. Anytime that you're putting barrier on your plans, make sure you have a typical section so we can see how that barrier is going to be laid out in relationship to the lane, what lane widths we're going to end up with. Are we going to have the 4 foot or 5 foot on the back side of the barrier? How is that all going to look? Provide a typical section anytime barrier is used. TMAs. On the design side for truck mounted attenuator usage, make sure we're providing enough quantity for the work operations. There will be times that on specific projects that contractors will need to use multiple TMAs in one work shift. It could be because we have a project that's 2 miles in length and they could have 2 different work crews that are separated apart. That crew may each need a TMA. So make sure we accommodate those needs in our quantities for the TMA usage. And that'll minimize any conflicts out in the field when safety goes out and asks where the contractor's TMA is. Also, when you're doing your quantities, make sure you account for the use of a TMA for removing and installing your temporary traffic control. That includes your advanced warning signs at the start of the project. That includes any lane closure, lane shift setups on a daily basis. If a TMA is required based on the requirements in the MUTCD, make sure we account for TMA usage for setting and removing temporary traffic control devices as well. Work at intersections. A couple things we've noted recently. We have some projects where we're installing channelizing islands, or we're removing channelizing islands, and how do we work around that? If we're closing a right turning path or a right turn lane at a pork chop island, we need to consider how that right turn path is going to be rerouted around the island. Unfortunately, I can't use laser pointer on this, but if you look at the plan and on the slide there, the corner, that sharp right angle corner, a truck cannot make that turn under that temporary traffic control situation. So we need to include provisions for how we're going to maintain traffic around that work area. Is it going to be a truck detour during the work stage there? Or is it going to be a permanent right turn closure where we've had to detour all right turning traffic? Some of that needs to be worked out in design and the proper provisions put in the plans so we know how we're going to maintain that traffic. When you look at intersection work in general, you want to try to sequence your intersection work to minimize the impact of traffic, to minimize how much maintenance traffic you're going to need. Maybe look at minimizing your conflicting vehicular paths. So in these cases, you consider turning restrictions or side street restrictions to reduce conflict points, especially if you are going to get in a situation where you're going to need a lot of flaggers to control traffic in an intersection. It might make sense to close certain turning movements so we don't need all those flaggers. Review, there's a memo on the Delaware MUTCD webpage related to intersection temporary traffic control that that provides guidance and best practices for this. Review that when you're putting your plans together for suggestions on how to deal with intersections, or reach out to the safety section for guidance as well. Make sure that if you're going to need temporary signal adjustments, we provide the notes or temporary signal plans for that. You also may need temporary signal timesheets, so coordinate with traffic on that as well. Pedestrian MOT, how to put this in here. We talk about pedestrian MOT a lot for a number of years now. It's still required. One thing we're seeing is a lot of good plan information on pedestrian MOT. Folks are really putting a lot of good information in their plans about ped MOT and how to address pedestrians. One thing I wanted to note here, and this is kind of a lesson learned, we need to be cognizant of how we sequence our work at the crosswalks and make sure that we account for use of pedestrian signals to get the pedestrians across major intersections. So that sequencing needs to be thought about in planning. They need specific notes requiring that a pedestrian signal can't be taken out until the new one's in place and activated. Those types of things. We want to make sure, or we may need flaggers to help escort the pedestrians across the intersection while the work is occurring. But at the end of the shift, we need to make sure that signalized pedestrian movement is available for pedestrians, unless they're detoured somewhere. Okay. All right, so on to construction. So for general compliance, again, kind of similar theme for design. We're going to start with some of the general stuff, and then we'll get into some of the details. General compliance, safety vests. Yes, I have to remind everyone, safety vests are still a requirement, and that will not change. Coordination with adjacent projects or work zones. Generally, you want to make sure that we're coordinating our projects, both in design and construction. We want to try to make sure we're avoiding signing overlaps, so we're not providing confusing information to motorists. And we want to definitely avoid overlapping maintenance of traffic. So we don't want situations where we have a left lane closure on the same road as a right lane closure that's separated by half a mile. That's just not going to work. So those types of things need to be coordinated. If those are needed, we can make them work, but we need to still do it properly. So safety vest picture there. Those in that picture there, those guys are just wearing little yellow vests. Those are not compliant. Safety vests, I'll go back to that in a minute, that must have the reflective strips, must be ANSI compliant, which is covered in the manual. Workers entering unprotected lanes of freeways. This is, there is guidance in the MUTCD under 6D03. Workers should not enter protected travel lanes of interstates, freeways, or expressways during planned activities. And that includes surveying, that includes sign placement, etc., including crossing the roadway to access the median or shoulder on the opposite side from the protected work area. We were able to get a picture of this from one of the cameras of this guy on Route 1 trying to cross Route 1 northbound in North Smyrna. He was actually putting his hand out to try to stop traffic while he was running across the street to grab a sign and pick it up. Quality of temporary traffic control devices. Make sure that, per section 801, that our devices are marginal or better based on the ATSA quality guidelines brochure. So that needs to be addressed in the field. And then taper lengths. I was asked to mention this as well. The lengths need to be based on tables 6C3 and 6C4 of the MUTCD. They need to be as long as possible to allow for proper shifting of traffic or proper merging of traffic approaching a lane closure or a lane shift. Work zone signage, sign storage. So at the end of the day, when your signs are no longer in use, they shall be removed from the roadway or placed behind positive protection. So, where we place them, behind the sidewalk, behind the curb, I'm not sure what's going on there. In front of the impact attenuator with no sign on it, or my favorite, on top of the impact attenuator that will go through the windshield when somebody hits the impact attenuator. Those signs need to be removed at the end of the work shift. Put back in the truck, put back in the yard somewhere, or placed behind positive protection, not on top of positive protection. Sign placement, make sure we're using the correct sign. We've seen situations where we try to take a sign and maybe rotate it a different way and try to put it in place for something where it doesn't mean, it's not in it for its intended meaning. We had one recently where somebody took a stop ahead sign, flipped it upside down so the arrow was pointing down, and it was at a stop line for a signalized intersection with the intention of meaning stop here on red, but that definitely doesn't get the meaning across. Unfortunately, I had a picture of that, but it wasn't clear enough to put in the slides. Make sure we're placing signs in accordance with the MUTCD and appropriate typical applications. So make sure that you're using the proper signs that are shown in the TAs for your lane closures or lane shifts. Ensure that when you're using sign stands like the high pro sign stands, make sure we orient them correctly. For the high pros, it's important because it's how they were crash tested. The short side of the base is installed towards approaching traffic. So the longer side of the base is positioned so that it's downstream of approaching traffic. Make sure signs are visible to motorists. We don't want signs covered by trees or anything like that. And obviously no blocking sidewalks or with signage. We want to make sure that pedestrians have a clear path, especially ADA requirements. We want to make sure that the folks that have wheelchairs or visually impaired, we make sure they have clear paths to walk along the sidewalks and aren't being obstructed by a temporary traffic control sign. Sign covering. So when we don't need a sign, we need to cover it. We're not going to remove it. We want to make sure that cover, the entire face of the sign is covered, not just a portion of the sign. So make sure there's nothing visible. There are use an approved sign cover as specified in section 810 of the standard spec. All right, TMA usage. So the MUTCD does provide requirements for TMA usage, section 6F86, paragraphs 5 through 8. Generally, it's for speeds greater than 40 miles an hour. If you want to read it as greater than or equal to 45 miles per hour. So when the TMA is required, we want to use it for appropriate operations, and that includes placement and removal of temporary traffic control devices. Which includes setting and removing advanced warning signs from the permanent warning sign plan. So on your permanent warning sign plan, when the contractor's out there installing the road work ahead sign on I-95, they need to have TMA behind them. When we're setting up and removing daily temporary warning signs for daily MOT setups. So when they're setting and removing their lane closures or the lane shifts, if a TMA is required for that roadway based on the speed, they need to have a TMA when they're setting the traffic control. If we're setting and removing detour signs, we need a deep TMA for that. Setting and removing cones, drums, barricades within the work zone. We need TMAs for those when the TMA is required per the manual. Note that in 6G23, there is a requirement that work shall not occur from the TMA vehicle. So if you're setting a cone line, and you have a cone truck or a stake body truck that they're deploying the cones from, the shadow vehicle with the TMA needs to be the vehicle behind that vehicle. So you need to have two vehicles in that setup, okay? If there's any questions on that, contact your district safety officer. They can provide more guidance on how that's supposed to be achieved. Typical applications will have requirements for TMA usage. So make sure that if you're using a link, TA33 or a TA10, make sure you check those typical application notes for your TMA requirements. The whole point of this is that safety is paramount for the workers and traveling public. We don't want somebody to get struck by an errant vehicle. That's what the purpose of the TMA is for. If the TMA is shadowing you as a worker, we want the TMA struck. They're designed to be struck. They're crash cushions. We do not want workers struck, and that's why we want to make sure that these TMA requirements are being followed to a T. If you're doing a rolling roadblock and it's a planned activity like patching potholes on I-95, and it's a rolling roadblock, every travel lane needs to have a TMA. That is a requirement per the manual. Not a DelDOT truck with arrow boards. It's a TMA that's required. If it's an emergency, might be a different story. But if it's a planned pothole patching event, we need TMAs out there. All right, so that's it on the construction side. So now just some general things that I wanted to touch on. Feel pretty good on time, I think. So related to MASH and how we're addressing MASH requirements for temporary traffic control. So as most of you know, NCHRP 350 devices are being phased out, mainly on the, we're focusing a lot on WB barriers, cast and plate concrete barriers, terminals, cable barriers, etc. Not a lot has been talked about related to temporary traffic control devices. So in 2009, when MASH came out, they anticipated that manufacturers would actually develop MASH compliant devices, but they didn't put a sunset date on previously approved devices that were tested under NCHRP 350. And so the feds realized that there was no safety benefits being realized from MASH. So in 2016, we had the joint implementation agreement from FHWA and AASHTO, which provided sunset dates for NCHRP 350 roadside hardware. They're all listed there. I'm not going to read them all, but that last bullet that's highlighted, there were specific requirements for work zone devices dependent on normal service life. So that was a little vague as far as how the states were supposed to handle work zone devices. So because of that, working with the MASH committee, DelDOT, wanted to look a little bit at this further. So in general, from a federal standpoint, devices manufactured after December 31st of 2019 must be successfully tested to the 2016 edition of MASH. So any new devices that are being manufactured right now, those all have to be MASH compliant. And that goes for sign stands, type 3 barricades, TMAs, etc. Devices that were manufactured on or before December 31st, 2019 and successfully tested to NCHRP 350 or the 2009 edition of MASH may continue to be used throughout their normal service lives. So that means that the department really has to kind of think about what is the normal service life of these devices. Well, if it gets struck, not long. But for things that don't get struck that often or haven't been struck, we want to realize the safety benefits of MASH. So we want to try to get some of this older hardware off of our roadways. So through the MASH committee, we developed specific sunset dates, Delaware-specific sunset dates on the which are noted on the approved products list for temporary traffic control devices, and they're here on the right side of the slide. Temporary sign stands, January 1st of 2023, and then the remaining devices, permanent sign stands, type 3 barricades, TMAs, temporary impact attenuators or sand crash cushion arrays, and temporary PCC safety barrier are all sunset on January 1st, 2025. So any projects after those dates that are bid and awarded will need to have MASH devices. So this affects the department-owned infrastructure as well as contractor inventories as well. So those are noted on the approved products list. There are MASH devices available for all of these, and more are coming and continue to come out from industry as we speak. And speaking of the approved products list, we do have one for temporary traffic control devices developed in 2018. We are continuously updating this with new devices as we get submittals from vendors. We're actually in the process now of developing a form that's going to be placed on the website for vendors to use to submit their new products. So we're going to try to streamline the process a little bit and make it clear for the vendors on how they're going to submit for getting on the approved products list. We will be making some updates. The current versions of the approved products list that are out there still refer to the older specs. There's some references to the 2001 specs. So that's going to be updated in the next week or so to reflect the current spec and pay item numbers. And we have the APLs for permanent sign stands, temporary sign stands, type 3 barricades, truck and trailer mounted attenuators, temporary impact attenuators, sand crash cushion arrays, and temporary PCC safety barrier. It includes pinned and unpinned barrier. The intent is to eliminate the need for our favorite NCHRP 350 packet. So the 2020 spec attempted to work on this. So there is guidance in the spec for how to, what to do with the APL. So make sure you check that out for how to move forward with not having the 350 packets. All right. So the last topic I want to touch on is smart work zones. Kind of want to showcase what we've been doing over the last several years related to smart work zones. We've been actually deploying what I would consider smart work zones since 2010. We did our first smart work zone project at the I-95 toll plaza. And what we did there is we used project money to advance purchase 6 portable changeable message signs. We put CDMA modems in there, and we put them in locations where we wanted to divert traffic away from 95 when there was delays. And those message boards, we had a specific plan in place for how we were going to activate those message boards. Those were based on, they would be activated based on TMC observations. So when TMC technicians were observing delays, there was a protocol in place for them to turn those message boards on to try to divert traffic away from I-95 or away from, the other routes in the area. We then did a queue detection system on 95 with the 95-141 Ramps GNF project. So this system was a contractor system that was deployed using message boards and contractor supplied detection devices as well. And there was a logic in place for when delays reach a certain threshold or speeds reduced to a certain threshold, those message boards would be automatically activated to divert traffic off of 995 northbound onto the noted diversion routes, 273, 141, et cetera, Route 1. So that we were fairly successful with that project, and the queue detection worked really well. We use remote programmable message boards on the Route 1 Frederica GSI project. Those were contractor supplied boards, and then the department put CDMA modems in those boards so that we could communicate with those. And again, using TMC staff, when we noted delays, those boards would be activated with different specific messages. We've been talking about smart work zones for SR24. There's an open-end task order-based contract that will be utilized. The system will be provided and maintained by a vendor with minimal department involvement. The devices will be linked to the TMC, to the website, to the app, et cetera. The devices will use DelDOT owned modems, but the equipment will be maintained and owned by the vendor. So that should be deployed here in a little while. I don't have a date on that yet. And then we have what I'm calling the mega smart work zone that's currently active on the I-95 corridor rehabilitation project. In this situation, we have contractor provided message boards with DelDOT modems. The consultant, WRA, developed the logic for the messaging plans, working with safety section. And we have different tiers on the messaging. So, and what we're doing is utilizing a lot of the existing infrastructure, the Bluetooth readers, the Wavetronics devices that we have in the field, that we've been putting in the field for a number of years now. We're utilizing all those systems to integrate this all together in one combined work zone management system. So if speeds reach, get less than 35 miles an hour on 2 or 3 different detectors on 95 approaching the work zone, then the first tier of messaging is activated. And then the intention there is to divert traffic off of 95, put traffic on 141, 495, et cetera. And then if travel times increase on those roads, then the second set of messaging is going to be displayed to the motorists, and we're going to try to use other diversion routes like Route 7 or Kirkwood Highway or Route 4. So that's in place now, and I have some screenshots of what that looks like. So this is the logic plan, the flow chart on the bottom right there, and then the message board locations. There are 16 total message boards that are deployed for the I-95 corridor smart work zone. Just a screenshot from the camera view. This is looking south on 95 at 202. This was on February 23rd. So this is when we were still setting up the contraflow pattern, but we had the southbound lane reductions in place. You can see traffic starting to queue up, approaching the camera there on southbound 95. And when we looked at the detectors, this is looking north at southbound 95. This is looking north towards the Brandywine River Bridge. So you can see traffic is really queued up there across the bridge. The 4 detectors that have highlighted there, those are the 4 that were to trigger the first tier messaging. So all 4 of those detectors needed to show speeds less than 35 miles per hour. Once we reach that threshold, then the first tier messaging is activated. And this is the log that we see in OpenTMS that shows when those messages were activated. And it was around 14:45 or 2:45 p.m. that the first tier messaging was activated. That in there. You can see that, so we used 2 of DelDOT's existing message boards, the one at the PA line on 95 southbound, one on 495, and then 4 of the portable message boards that were supplied by the contractor. All those boards were activated with tier 1 messaging, again, diverting traffic away from 95, trying to push traffic to use 495, and then folks on 495, giving them guidance on how to get into the city of Wilmington. Just a screenshot of what the messages look like here that we see on our end on the screen. So you can see the different messages. 95 south blaze ahead, use exit 8. So again, trying to divert traffic off onto 202. You have them go up to 141, and then we have if you're on 495, traffic to Wilmington or to Center City, use exit 3. So that's the 12th Street exit. Try to give that guidance to the motorists as we try to activate that message. What ends up happening is we see those messages will activate. In this case, I think the messages were activated for about 5 minutes. The speeds on the detectors actually increased a little bit. The congestion was slightly reduced, and the messages went back to the original messages that were displayed prior, that were just informing road users of the road work ahead. And what we've seen over the last several weeks is that will happen. We'll get a little spot of congestion. The messages will activate, and 10, 15, 20 minutes later, once traffic starts diverting, and we get the rest of that queued up traffic through the work zone, those messages will go back to normal. The system will go back to normal. And generally, we don't see another system activation until the next day. So the systems were working very well, and we've got some good lessons learned on how to continue to improve this system as we progress. We are making some changes to the logic to kind of address how we've seen traffic, and so those improvements will be forthcoming in the next week or so. But it's working out really well. So some of the neat things that safety sections and TNC and other folks within DelDOT have been involved with on our projects recently. So with that, I will take any questions that have come into the Q&A session.
Okay, we have one so far.
All right.
I think you might have touched on this, but it's from Garrett Purdick from ACOM. I noticed over the weekend the traffic control on I-95 has been revised. Was this due to the amount of accidents that occurred during the first few weeks of this layout? And will this be the focus of DelDOT to look at MOT layouts that aren't working as well as it was thought they would, and what can be done to improve them?
So I think, one of the things that the safety section has always strive to do is make adjustments where necessary when we see things aren't working just as well. And that's one of the reasons why the safety officers come out to the job sites. They're looking at those types of things. So yes, I think that's something that's been ongoing at the department for years to try to address specific issues that we're seeing or might be related to crashes or congestion and try to make things better. I'm not specifically familiar with what changes were made this weekend on the Viaduct project, but I can probably try to get more information on that.
That's all we have.
All right, great.
Thank you very much, Adam.
Thank you.
And Adam's coming back later, so if you have more questions, feel free to submit them in the Q&A. So next, we will have Eric Simo, who's going to be presenting on the Private and public utilities coordination, missed utility and right-of-way needs for our projects.
While we're trying to get that brought up, I'll just reiterate what John said. I'm Eric Simo, the state utility engineer. The title was a bit of a mouthful, and I was asked to come in and just talk about some of the utility related items. So I just called it Utilities Update, try to keep it a little more simplistic. And I want to reiterate something that John Day had mentioned earlier, and that's the notion of being good neighbors. Don't forget, utilities are our neighbors too. I know sometimes it may be difficult, but we need to treat them as good neighbors as well. All sorts of struggles. While we're working through that, so some of the things that John had mentioned previously, I'm going to touch on this utility. I'm going to touch on private and public utilities, talk a little bit about design, utility coordination during design, advanced utility work and that coordination and inspection effort, and then the highway contractor and their coordination effort with utilities. So from the missed utility standpoint, missed utility is outlined as part of Delaware Code. So it is a risk-based process or system that was created to try to reduce the number of underground strikes of utility lines. It's a free system that can be used during design and construction. It's free to the folks that are submitting tickets, and it's paid for through the utility company or missed utility members for every ticket that goes in. For the point of this conversation, I just want to outline some things on the excavation or dig ticket side. So I'm not going to touch on the design ticket side. So placing the ticket, tickets should be placed at least 2 working days ahead of planned work, but not more than 10 days ahead of planned work. It is important that excavation work is not started until positive responses have been received for all the companies identified on the ticket. Thanks. So if you have your list of companies on the ticket and you don't have a positive response, then don't start excavation. Positive response would typically mean either clear no conflict or marked. If you notice that there's an issue with what's showing up in the ticket versus what's happening in the field, then you need to file a discrepancy ticket. For instance, if a company, let's say Verizon, responds within minutes of your ticket going in and says, clear no conflict, but you know that there are underground Verizon facilities, or you see evidence of underground Verizon facilities, you're going to want to put a discrepancy ticket in. What that does is it actually it unlocks the status so that the utility company or their locating firm can then go back in and re-status the ticket once they've provided marks or once they've really looked at it and cleared it. Meeting requests. So one type of ticket that can be submitted is for a meeting request. And essentially what that is for larger projects, which the majority of DelDOT's projects qualify for larger projects, the excavator can put in a meeting request ticket, and that provides the ability for the contractor and the utility and their locating firm to meet, talk about the project, talk about the needs and when work's happening, where work's happening, and to establish mutually agreeable terms for how the mark out is going to occur moving forward. We've had some issues with companies not responding to utility tickets, and this has been utilized on a couple of projects recently, Elkton Road being an example, and it seemed to have helped with the companies not being able to keep up and provide the responses on tickets. So please keep that in mind. Protect and maintain the marks. So once a utility does provide marks in the field, it's important that the contractor try to protect and maintain those. Now, obviously, depending on the type of work you're doing, those marks are going to be obliterated if you're digging in the area and whatnot, but we should try to do everything we can to protect and maintain them. And if you know it's going to be a heavily traveled area, maybe take some additional, do some additional things to set up ways to permanently mark so that then it's not an issue. Ticket life. So tickets remain valid as long as work on the ticket that's been submitted has started within 10 days and is within the scope of the work outlined, and as long as the marks are still there to work off of. So that is, there's a lot of confusion around that. The tickets don't expire, but if a contractor stops work on the ticket for some period of time, they can't just pick back up and work under the same ticket. They would have to place a new ticket prior to resuming any excavation. And the big thing to keep in mind here is resources, right? So utility companies and our locate firms get a lot of tickets in a day, like hundreds, maybe even thousands, depending on the entity. And so we need to try to manage our tickets in order to have them respond as efficiently and quickly as we would like. We do get a lot of reports for especially DelDOT contracts where tickets are called in every week with no change. And it could be months where there's no work happening, but yet the tickets still go in. Well, by law, the utility company is required to respond to those, even though we're not working, and we know we're not working, and that causes a lot of issues. So if we want the responses to get better, we need to start helping to manage things a little better too. All right. So private versus public. So it's entirely possible within project limits of any of our highway projects that you're going to come across facilities that are not owned, operated, maintained by utility companies. In our world, we'll call those private utilities. And so essentially that's something that's owned or the responsibility of a property owner or a different entity. Typically speaking, those entities will not be members of Miss Utility, so you will not be receiving marks. So for instance, a lateral that runs from the sewer back to a house, you're not going to receive marks once that lateral leaves the right of way. I'll get into that a little bit later. And once that leaves the right of way, it's the property owner's responsibility. So The only way to obtain that information in a lot of cases is to actually get it from the property owner. We don't usually have records of this information. In some cases, when we're coordinating with the utility companies during design, we'll be able to get like cut-in cards or something that might indicate where they have service connections. But then once it leaves their responsibility, we don't know what it does. So then how do you find it? So we'll utilize subsurface utility engineering during design. And in some cases, that might help us understand and find the facilities. Again, sometimes the utility companies might have something, but really the only way to find a lot of these is to talk to the owner, usually the property owner, to find out what they have on the site. That is not something that's handled through the utility side of the world, and maybe something on projects where between the design side and the real estate side, discussions may need to be had. So here's an image I stole from the Miss Utility side of the world, from One Call Concepts, who is the firm that runs the call center for Miss Utility. It's not perfect, and every situation is going to be different, depending on the utility, depending on where you're at. But what this is trying to do is it's trying to illustrate what's a utilities versus what's private. And so anything that becomes a dashed line in this illustration is showing you that that's actually owned by the property owner or is private. As you can see, the majority of the facilities in the right-of-way are owned and operated by the utility company. They would be handled through a Miss Utility ticket through that one call system. However, once you leave the right-of-way, you see a lot of dashed lines. Again, that ownership is turned over to whoever owns the property. And in some cases, like with secondary facilities, like running to the garage or the swimming pool or lighting, the utility company doesn't even know that it's there. And for some other examples, because these are ones that have come up very recently, in the top left, irrigation. So whether it's a home or a business, if they have a sprinkler system, that is not something that Miss Utility is going to locate. The only way you're going to know that's there is if you see the heads or you see the head grade lids for like their valves and stuff like that. Or if the property owner tells the real estate side or the design side about those facilities as part of the coordination during design. Obviously, when the contractor gets in the picture, if we don't know that these are there, that can become a problem. But I want to point that out. And same goes for farmers as well. There's times where farmers might own fields on both sides of the road. And so they may be given permission to install a water line under the road. That water line's private, won't be marked as part of Miss Utility. Hopefully there are permanent markers that are installed at the right-of-way line to help indicate the facility's there. But if that information isn't provided through the property owner, it's not going to be known as part of the design, and the contractor will have no idea. And if any of those facilities are encountered or struck during construction, it becomes the state and the contractor's responsibility to fix those items. And then the larger picture I have kind of in the background there, I stole that from Brianna, but it's from our CRTC project. That is a wooden duct bank that Amtrak has their communication facilities running in. Amtrak is not part of Miss Utility. So they will not mark out through the one call system. So you have to actually talk to them to obtain information on their facilities and to have somebody provide that insight in the field. Or else, as we found out on some projects, the contractor may run into it and cause serious issues. So jumping into coordination during design. So my side of the world, this is the bulk of what we do. So we coordinate with the utility companies throughout the design of a project. Ultimately, what we generate from that coordination is information in the plan set that's provided to the designers, but then also a utility statement. That statement summarizes the existing facilities and the proposed work or relocations that are going to happen for the utility companies. It also provides work durations for the utility relocations when needed. And should also have a relocation bar chart associated with it. On the bar chart side, this is important because not just does it outline the duration, but it shows the sequence of how the work is anticipated to go. For instance, you might have the electric company performing their relocations first, followed by one of the comms companies, then the other, and so on, and it'll work you down through what that is anticipated to look like, because not all the utilities can relocate at the same time, and usually one company's work depends on the other. The other piece with the bar charts is they're coordinated during design based on the anticipated project phasing, and I underline anticipated there. I'll touch on it later, but that's very important. So whatever the phasing of the project is, or is contemplated to be during design, that's what we're working with the utility companies on. Then if there's any reimbursable items with utility companies, we will generate utility agreements. Our agreements have become more detailed over the years. So as you can see here, the items I sub-bulleted are what is included in the agreements. So we outline what the work is, who's responsible for the work. There's times where we, DelDOT, are going to have our contractor perform certain pieces of work or that we're responsible to pay. And there's other times where, like in the case of betterment, maybe we're doing the work with our contractor utility company, but ultimately they're going to be paying us for that. So we'll outline all of that in the agreement and the exhibits. And then we'll have estimates in there to show what those costs are anticipated to be. And again, we'll have the relocation bar chart or anticipated timeframes for what that work, how that work's going to happen. So if there's changes to the design or the schedule or the construction methods, it's important to note that all of the work that we've done to coordinate these utility relocations could all have to start all over again. So it doesn't matter if we're adding work into a project during design. It doesn't matter if we decide to change the phasing. And it doesn't matter if when the contractor gets in the picture, they propose changes. Whatever we've coordinated with the utility companies needs to be revisited at that point. So let's jump into advanced work. We seem to utilize advanced work pretty regularly, or at least we try to. There's usually items that need to be in place for us to move forward with advanced utility work, such as having right-of-way cleared, meaning we actually have the right-of-way to go out and do the work. Clearing and grading is sometimes needed. Depending on the nature, we may be able to get the utility companies to perform some of the clearing and or grading, but that's something that needs to be discussed during design so that we're all on the same page. MOT, we need to understand what the project MOT looks like, because that applies to utility companies as well. So going into Adam's presentation, like if we don't have those charts that indicate what the allowable lane closure times are, then we're not going to be able to move forward with work, because we need to understand what those impacts are. We need to have funding in place. So our section will work with whoever the project manager is to make sure that all that stuff gets put in place, and then we'll issue the notice to proceed for any reimbursable work. And then stakeout. Any utility work is going to need some form of stakeout, whether it's staking the proposed relocations or staking right-of-way, PE, curb, pavement, all that stuff. So since this work is happening in advance, it's beneficial to have somebody out in the field overseeing the work. And we've used advanced inspection on a good number of projects now, and it's definitely been crucial and a huge benefit. So there's a lot of questions that come up when the utilities are working. You know, they're out there before anything's been done to the roadway or anything like that. So they're working off of an existing condition, and they can't see what the improvements are going to be. So having that advanced inspector on site to be able to help provide guidance and make sure that their facilities are going in accordance with what the highway plans indicate is definitely a big help. We look for those inspectors to reach out to companies and discuss their work and the timing of their work, be proactive, circle back, make sure all the different companies understand what's going on, and that they understand the stakeout that's been provided too. So we've definitely had situations over the years where all the stakes are provided as requested, but then maybe we had to do offset stakes instead of being able to stake out a direct alignment or something. And the the utility company misinterprets that information and goes in the wrong place. That's why it's good to have inspectors on site to help figure that out before the utility goes in the ground. And then keep everybody notified of progress and if there's changes. Just like for our projects on the design side, there might be stuff that comes up in construction that wasn't really anticipated during design, so there need to be field changes. Well, the same thing happens on the utility side. What's on paper doesn't always work from the field side, so it's good to have somebody that's able to chase things down and try to keep things moving. And like I just said, just to handle any questions and issues that come up. And then ultimately, if we have reimbursable work on a project, we're going to want to verify that all of the items that we're paying for were done as they should have been. So we'll actually, my side of the world will end up going back to whoever the inspector was to verify the work happened and that the reimbursables are okay before we pay the utility. And then lastly, just trying to be able to obtain some as-built information and just having a knowledge for what's happened on the site for when that highway project comes into the picture. And then jumping into when the highway contractor comes in. So the highway contractor needs to coordinate with utility companies as outlined in our standard specs and in accordance with utility statement. They need to provide advance notice when needed. Again, that's part of the utility statement. It typically gives the amount of advance notice each utility company requires. And that needs to be done by the highway contractor. So they also need to notify companies of any anticipated changes or approved changes. Again, getting back to what I said in one of the previous slides, this becomes crucial. If something changes, it could greatly impact what was anticipated from a utility relocation standpoint. And either it could make it so utility companies can't perform the work they were trying to do, or that the contractor has now made it so the utility company can't work because they're working in the same area. And then lastly, just coordinate and communicate with companies throughout the project. And that's crucial. As long as communication is going well, then we can get through a lot of issues or concerns. So that's it. Hopefully that provided some helpful insight. I'll take any questions if we have any.
Yeah, we have one. It says the specifications don't really address DelDOT or the contractor's responsibilities for private utility facilities located within the work zone. Should we look into putting language in the 100 section to address this issue? Sure.
Yeah, that's a tough item because if you don't know it's there, it's very hard to find it. So you really have to rely on typically the property owners, and even in those cases, you could be talking about facilities that were installed before the person owned the property. So you do the best you can. So yeah, that process.
Yeah. That was it. Thank you, Eric.
Well, thank you all.
Okay. All right. With that, we're actually going to move the break up to look at some of the technical issues we've been having. So stay tuned. We're going to take a 15-minute break. So at 2:30, we'll be back, and Sarah Esposito will be talking to us about the permanent BMPs. Thank you. the panelists and the All right, welcome back, everybody. So we moved the break up a little bit and moved things around. So we next have Sarah Esposito from the NPDES group here to discuss BMP acceptance and as-built.
Good afternoon, everyone. Thanks for the introduction, John. My topics are a little bit different. I'm going to be doing some lessons learned on our maintenance contracts and then as well as construction. To reiterate, I'm Sarah Esposito, the NPDES program manager. So here we go. Before I get started into the BMPs, I just wanted to touch base on some of our restoration projects. We haven't had these street restorations in construction for the last couple of years, but we have several in the queue, starting with Harvey Road channel modification, which is going to upgrade a severely eroded concrete swale and incorporate a rock cascade to safely bring the water down a steep gradient. And then our next two, the Rob Scott Manor Stream Restoration and the Drag and Run Stream Restoration at Kingsville Mobile Home Park, are in support of our Christina River and Drag and Run water quality improvement plans that are part of our Phase 1 MS4 permit. So you'll be seeing those through semifinal and final design stages soon. Down below is a cross-section from our Rob Scott Stream Restoration, and it shows a small low flow channel in the center and then a large floodplain area that we're going to construct. And that helps when storm flows. Anything over a 1-year storm will access the floodplain, and that helps reduce energy in the system and reduce erosion. Currently, the stream is very incised, steep side banks, and that creates a lot of erosion in the system, as when it rains, all that storm energy is contained in the side banks. It can't release out. So switching gears into our BMPs, which are, that's short for best management practices, which is a nickname for permanent stormwater management facilities. At the end of during the course of 2020, we inspected 625 BMPs that DelDOT maintains. That number has stayed relatively the same over the last couple of years, even though we have been accepting projects that have BMPs in them. We've also worked with Pcc and Tools, who handles the Service Plaza, and eliminated some of those BMPs from our maintenance records because they're maintained by other entities. At the bottom there, you can see the percentage of BMPs in the different categories. A, B, C, and D, where A is in good condition, C is minor maintenance, B is minor maintenance, C is major maintenance, and D is failing or in need of a retrofit. And you can see the percentage from 2020 and 2019, where we've really increased our amount of A BMPs over the course of that time and reduced our number of B, C, and Ds, which is the direction that we're obviously trying to go to. 2020 was either the end of 2019 or the beginning of 2020 was the first time that DENRC has been requesting that we submit our maintenance records of our BMPs to them twice a year. So they are now getting that data, which is why we're trying to track them in the positive direction, better quality, better maintained BMPs. We're not exactly sure what they're doing with all that data, but they're getting it. So we want to make sure that we're continuing to show improvements. And this just shows that same information graphically by maintenance area. And you can see pretty much all the maintenance areas have at least 20 BMPs that they are responsible for, with the exception of Laurel. They got their first BMP about 2 years ago. So they only have one, but all the other districts have at least 20. And you can see Middletown already has over 100 BMPs that they have to maintain. And that number will increase with the acceptance of US 301. 301 has over 80 BMPs. They're pretty close to acceptance at this point. And those will be split between the Canal Expressways yard if the BMP is directly on 301, or the Middletown yard if it's on one of the adjacent roadways. And you can see all the yards have a pretty similar breakdown of mostly A's and B's and a few C's and D's. They're all doing, they're all trying to do a good job maintaining our BMPs, but they have a lot, and more just keep getting added every time we approve another project. So the districts handle any minor maintenance, which would be our B-rated BMPs, and we coordinate the major maintenance of C and D-rated BMPs. And we've also been working with construction to get good quality BMPs out of construction so that they're coming in as A's and we can hopefully maintain them as that versus having to do maintenance on them as soon as they are accepted. So next I'm going to focus on one of our major maintenance contracts that has been ongoing since 2019. It's just wrapping up. It's with Diamond Hill, the contractor. Fabulous job maintaining 13 original BMPs and 3 change order locations. And Canal District helped us manage the contract, which was a huge help. Altogether, we spent over $1.6 million on the contract, which equates to about $100,000 per BMP. It was originally a major maintenance contract, but a few of the locations ended up being retrofits. So the retrofits ended up costing a little bit more, major maintenance a little bit less, but all in all about $100,000 per BMP to do major maintenance work. I'm going to focus on 2 of the locations, BMP 143 and 431. Both of these are dry ponds. I'm going to start with 431. This is on SR1 northbound, just south of Odessa. It was originally built back in 1996, plus or minus, from what I could tell. And it was designed with a 0.67% bottom slope. And the theme of these dry ponds is when you have a very flat bottom slope, they turn into a wet, mucky maintenance nightmare. They don't drain in between storms. They're very saturated. Then it's difficult to mow. If we do try to mow, the mowers might get stuck and start rutting up the bottom, which then causes more ponding. And then cattails and phragmites love that kind of mucky, saturated soil conditions. So they start moving in, and eventually we get a BMP that looks like this, or worse. This is actually maybe on towards the better side of a dry pond photo that's gone to the wayside. And here's another view of it looking towards the outlet structure, and you can see the forebay on the right, and that forebay discharged into the pond and just kind of sits and oozes there, and it doesn't drain adequately. So we came in and put in a low flow channel through the center of the pond, and that provided almost immediate relief to the system. The basin bottom's now dry in between storms. They can mow it. It's really holding up well. And this is turning around towards the outlet structure. At the end of the low flow channel, we put on a micro pool. And you can see right in front of Edwin there, a riprap channel connecting the forebay to that micro pool. So you no longer have that water just sitting there stagnant. So this pond looks really great. It should be A-rated, but one of the lessons learned here, unfortunately, it's still rated a C per our standards, and that's because of the outfall of the pond. You can see this photo here, the right-of-way fence and the geotextile suspended in air due to the erosion that's occurred. And this goes back to the original design of the pond. The discharge from the outlet structure was put mid-hill. It was towards the lower end of a steep gradient, but below it is still a significant enough gradient that a large amount of erosion resulted downstream of the riprap protection. So it's a important topic. I think I've stressed this in other lessons learned or BMP talks that we can't be discharging mid-hill at the top of the hill. We have to be bringing that conveyance all the way to a stable foundation at the bottom of the hill. If not, erosion is going to result and we'll have to go back. Fortunately, at the time, the erosion is outside of our right-of-way, so an easement would have been needed, and we didn't have enough resources to include it at the time, mostly time-wise, to include it, but it's on our list to eventually go back to. Switching gears to BMP 143, this is on Route 141. This was built in 1987. The details on the plans are pretty much non-existent for the pond itself, but based on the inverts of the incoming heights and the outlet structure, it was designed with a zero slope in the dry pond. That created that wet, mucky maintenance nightmare with cattails and frag. And at some point in the past, the low flow orifice was plugged to convert it into a wet pond because of complaints from surrounding citizens about the appearance of the pond. And while that helped in making it look like a wet pond, that plugging the low flow orifice backed water up into the under drains and storm drains under 141. So during the rehabilitation project, we worked with construction and AECOM to design a retrofit to alleviate that standing water underneath the roadway. Here's a photo of the pond right before construction. It's actively being dewatered at this point, so it looks kind of like the dry pond it was supposed to be. And the goal of the retrofit was to convert it into a wet pond by placing the permanent pool kind of just at under the existing dry ground bottom elevation. And we added benches depth. Originally, the design plans called for a new principal spillway and emergency spillway. Fortunately, just following the utility presentation, a gas line was not marked during the design stages of the layout. Luckily, prior to construction, it was located, so we were able to do a test pit and determined that the elevation would not allow for the emergency spillway to be constructed. The gas main wouldn't have enough cover over it. So we ended up leaving the existing outlet structure in as the emergency spillway and cut in additional weirs into that box. And then we were still able to add the new principal spillway because the storm drain pipe was located below the gas line, and then we could backfill and have enough cover. Here's a photo during construction. It was difficult for them. It was very wet. They had to bring in geomats to be able to move the equipment on so they didn't sink into the muck. There was constantly water flowing in from groundwater flowing in through the pipes. That just created a wet mess. But they did a great job. Here you can see it starting to take form with the permanent pool and the safety benches. You can see the two outlet structures in the back, the existing and the proposed one. And then you can see the pump there that they continually had a pump while they were working. That's one of the lessons learned. They originally didn't have the bag located on a stable base, so I kind of had a poly liner underneath to make sure that we weren't causing erosion problems by pumping. And they had to change that bag up pretty frequently due to the amount of water that they were pumping to do the construction. But luckily for the time of year, springtime last year, we got great initial stabilization for the project. And here's a view looking at the two outlet structures where we modified the existing and added the proposed one. And here's a photo from this fall. You can see great initial stabilization. Unfortunately, cattails and frag did quickly grow again, but the major reason for the project was to alleviate the standing water under 141. And that was achieved through the project. This photo shows, this is one of the first BMPs, I believe, that was constructed with the new stormwater seed mix, and you can see the initial growth of some of the native wildflowering grasses in this photo. This photo here, I was originally going to show a third dry pond with a very similar story, originally designed with a flat bottom, and then turned into a maintenance nightmare. But I cut it out due to time, but I added I left this photo here. It's in the stream that the BMP discharges to. And originally the right-of-way fence was constructed across the stream, which just immediately gets clogged with debris. And then the water has to find a different way, which is either around or underneath. It creates a lot of scour. So just something to think about if you're installing right-of-way fence for a project. You need to be thinking what we're doing across streams, because just putting it right across doesn't work. The photo doesn't really show it too well, but there's a large amount of scour around there. Just the vegetation and the time of year kind of limits how much you can see. So to wrap up, dry ponds, they must have a bottom slope. I'm going for 2% as the minimum. I know that can be difficult, but if not, it's just not viable to maintain. If you're somewhere between that 1% and 2% bottom slope, maybe there's ways that we can help the situation by adding in a low flow channel. And then the other thing that we're starting to consider would be biochar amended to the basin bottom. Biochar increases runoff reduction, and which we've been working with the University of Delaware to study on our roadway side slopes. And the thought here with the dry pond is if it's helping to dry out that basin bottom in between storms, and our mowers can get in there and mow. So we're looking to start some trials. So if you have any dry ponds that are in design and don't need the 2% bottom slope, reach out to me or Steve Wright, and we can work in incorporating biochar into those basin bottoms. Or consider a different BMP. If you just can't get that 2%, think about incorporating a different BMP. Moving on to infiltration basins. The first one that I'm going to highlight is BMP 670, which is on US 301. It was built on a clay lens with high groundwater. It, in essence, never should have been built in its location for numerous factors, not associated with one entity. There's many reasons why, both for this location and other infiltrations across the state that aren't working. But to highlight this one, this photo is from 2018. There was 0.4 inches of rain 2 days before, so it should have been mostly dry at this point. This photo is from 2019, and there was 3 days of no rain. This photo was taken, so it should have been fully dry. This photo is right before we went in and tried to do some work in 2020, and that had 8 days of no rain before. And you can still see that it's saturated. And this basin has a pretty small drainage area because it's also built to handle the future spur road off of 301. So it's not receiving half of the drainage area that it's designed to. So it makes these photos even worse because it's not receiving that much runoff. So initially, construction was, we worked with construction and they got some bids to put in stone trenches, which I'm going to show a project where that was successful in next. But those stone trenches, ideally would have cut through the bad soil and allowed the water to infiltrate through them. But the cost was very high, and around the same time, the professor that we work with for the biochar research mentioned this soil fracking technology. And essentially they drill down 6 feet and then blast high pressure air, and that air works its way back to the surface and creates fissure lines as it does that. And then they accompany it with a media to fill those voids. So here's a photo of them in action. And here's a little diagram of what I was just talking about. So they drill down the 6 feet and then blast the air, and that air forms all these fissure lines in the soil. I'm going to play a quick video that shows the machine in action. You'll see towards the end, he kind of steps away as it's drilling down. And then when he walks back to the machine, that's when he's getting ready to blast the air. He was basically waiting for the compressor to meet its PSI. And then after he hits it, tells it to go, you can see the ground move underneath the machine as it blasts the air. And here he is drilling down. Not sure if you were hearing sound, but if you were hearing sound, it was very loud because it was had a jackhammer the entire time because of the high plate content. Again, he's waiting for the tanks to reach the correct PSI and then watch the ground underneath. I don't know how well you saw it with the remote, but the whole machine kind of picked up almost like a waterbed when that air was blasted in. And I have another video, it's a little shorter, and this is down kind of more towards the lower limits where it's a lot wetter. And all the flags are where they've already done the boreholes. And as they drill down and blast the air, you can see the groundwater coming out through those previous holes. So it's almost like a little geyser in between the equipment and the guide. And then this photo is after, again, all the flags represent where they did those boreholes. They did a 6x6 grid throughout the whole basin bottom. And this photo, it rained about half an inch that morning. So it had just rained, but I could have come, this photo could have been 3 days after, and the water would have been in there. So unfortunately, our trial didn't work that great. The system was too compromised for it to make that much of an impact. I am sold on the theory though, and so we're looking for other locations where we can possibly incorporate a better spot. So switching gears to a little bit more successful of an infiltration story. This is the South Fred project. BMPs 530 and 531 were infiltration basins. They're on the south side or the lower end of the screen, and then the upper end of the screen are wet ponds. In this photo from 2018, they all look the same because the infiltration basins weren't functioning. This photo is from 2018. It shows it had a tenth of rain the day before, and then 3 days before it had 2 inches of rain. But so probably should have been a little wet, but not to this degree. And construction also noted that it was ponding water kind of throughout its life. So we worked with construction and Century to design these stone trenches that kind of punched through the bad soil and gave a location for the water to infiltrate. We did 3 roughly 17 by 17 squares in the basin bottom, and then they also disked the bottom of the basin to loosen any compaction related issues. This photo is 4 days after no rain, and it shows the dry basin bottom, and you can see the 3 stone trench areas circled there. Similarly for sister pond 531, this photo is at the same time period in 2018 beforehand. For this one, the soils, we decided just to remove 1 inch of silt from the top and then disc the basin bottom. And this photo is 4 days after no rain, and it shows the dry basin bottom. So that was promising and hopefully succeeded in rehabbing that infiltration. So some infiltration lessons learned. Many of the failures on US 301 and throughout the state are in A24 soils. That was noted by Vince Davis and Adam Marvin, who's the US 301 stormwater engineer. I think we need to take a close look at all infiltration basins, but particularly A24 soils to make sure that it's going to function long term. The soil samples have to be in the basin bottom. That is a stormwater reg, but we've noticed a couple of locations where there's been issues. The soil samples weren't taken in the basin bottom. There has to be a minimum of 2 per facility, and the stormwater regs have been updated to include more depending on your basin size. So they have some thresholds. So if you have a large facility, you're going to need more than 2 samples. One of the biggest reasons I think we've seen a lot of failures in our infiltration basins is we weren't previously noting the seasonal high groundwater, and the basin bottom has to be a minimum of 2 feet above the seasonal high. And I think if we have been capturing that in the past, a lot of the problem BMPs that we've seen would have been eliminated earlier on in the design process. But all that being said, we're not alone in this. Other states are seeing very similar infiltration woes. Where it works well. I used to be a huge proponent of infiltration before I joined DelDOT. It can definitely work. It's not always doomed, but you have to have the right underlying soils for it to work, and they have to be protected during construction. I've also come to realize that maybe it's not smart for us to be setting our road run off into the groundwater. During the winter months, we put a lot of salt down on our roadways, and then we're just injecting that basically into our groundwater through infiltration basins. So that's something that we'll need to consider moving forward long term. So all in all, it may be wise to choose a different BMP than infiltration. Especially where the soils don't support it. You can't force it where it doesn't want to be. So I kind of indicated dry ponds may not be the best, and I sort of indicated infiltration basins may not be the best. So unfortunately, I think that leaves us with wet ponds. I think they're the BMP of the past, present, and the future. With some caveats. The past, our wet ponds get inundated with cattail and Phragmites. We work hard to prevent that. This was undergoing major maintenance to remove a lot of the cattails and frag from this BMP. When we also spray every fall all our BMPs that have cattail and frag. So as we move forward to the future, I would like them looking more like this. This is one of our BMPs down in the Fenwick area that was planted with aquatic plugs during construction, and it looks great. There is a little bit of cattail growing in it, but very minor compared to how our wet ponds normally look. So I'm probably going to be pushing this moving forward to start incorporating aquatic plants on our aquatic benches to thwart off the growth of cattails and frag. that's that. So I'm going to end with my same slide that I did in winter workshop, just a shout out to call 302 stop it. If you see anything water quality wise that shouldn't be there, we will go out and look at it and inspect it both personally at your home residence or on the job. I'll call it in, whether it be 302 stop it, myself, my team, or even TMC. Just see something that's not supposed to be there. Do something about it. Thank you.
Thank you very much, Sarah. We have a question, but if you could stick around and answer it with Bob, through the chat, sure, we appreciate it. Trying to keep on schedule, we're gonna move on to guardrail and match discussion. We're gonna bring back Adam Weiser to present on this topic.
Good afternoon again. Good afternoon again. So I'm going to talk about guardrail and MASH updates. I know most of you have heard some of this in the winter workshop, but I'm going to kind of tie it into some of the lessons learned as well. Not sure what happened to my fonts there, but we'll get this. All right, so I'm going to just briefly talk about MASH implementation. And then I'm going to get into standard construction detail updates, just a quick summary of what we talked about in the training last year, and focus on guardrail and some common field issues, quickly touch on concrete barrier, and get into the approved products list. So as I said before in my work zone presentation, we have the MASH implementation agreement with the feds. We have various sunset dates for roadside hardware. We've been past all of those sunset dates at this point. So basically anything that we're installing now, roadside hardware, with the exception of like signposts and light pole standards and such things like that we haven't quite gotten the MASH devices available for, but like W-beam barriers, our end terminals, crash cushions, cable barriers, concrete barrier, bridge railings, all that stuff is now needs to be now MASH compliant. We as the user agency, DelDOT as a user agency, determines MASH compliance based on some memos from the feds over the last couple of years. Obviously, the policy is that all roadside safety hardware installed in the national highway system is to be crashworthy. It's the state's responsibility to determine crashworthiness and to approve new or modified roadside safety hardware that meets our needs. So we do that at the state level. Implementation status. We are in pretty good shape with the W-beam barrier, W-beam terminals. We have the approved products list for guardrail end terminals, as well as the permanent impact attenuators. We have an approved products list for that as well. Bridge railing, I know the bridge section was working hard on getting the bridge standards updated for MASH compliance, and I believe most of that's in place now. Guardrail transitions with the last standard detail update, with the last standard detail update, the guardrail transitions were brought into MASH compliance. And then the only thing we're missing at this point are the sign supports, other breakaway hardware, like I said, light standards, the community entrance signs, those types of things are still being worked on as we speak. As most of you know, we have a MASH committee. This is now a formal MASH committee through policy implement that was recently published. The purpose is to, the primary purpose is to serve as the technical group regarding roadside safety hardware. Working with the standard details, recommending roadside safety hardware for the approved products list. So they will be the reviewers of recommendations for devices to be added to the approved products list, establishing Delaware specific sunset dates. So through the MASH committee, as I talked about in my last presentation, the MASH committee established sunset dates for the temporary traffic control device hardware. And then reviewing recommendations for approval of devices that are exempt from MASH certification also as part of the committee. And the committee is made up of various staff from various sections of the department, so that maintenance, construction, design, safety, all those folks kind of have a say in what's going on. Again, you know, if from a MASH committee standpoint, if the hardware, roadside hardware has approved crash testing from a recognized crash testing facility, generally will be approved without self-certification. And then other devices that don't necessarily have like a FHWA, what we call an eligibility letter, what used to be called 350 letter, if the device does not have that, then there would be more review required from the MASH committee to determine if it's a device that can be added to our inventory or installed in the state. All right, so, all right, for the guardrails, we're gonna jump into guardrails. So update summary on the guardrails. We did an overall MASH compliance review last year with the standard details. We added a few new details. We added the guardrail with omitted post. That's with and without curb, and I'll get into that in a minute. Guardrail on steep slopes, and we added new guardrail to barrier connections. A revised end anchorage design and buried and back slope designs were also revised. This is a list of all the standard details that are available that are guardrail related. I'm not going to read through all of those right now. A couple things I want to hit on with guardrail applications with the detail B1. So this, the top in the picture is the type 131 that has a 4-foot deflection. So the required space behind the guardrail post to the obstruction is 4 feet. The 231, which is in the middle of that plan there, that minimum deflection is 2 feet 6 inches. So that is the minimum amount of space that can be between the back of the post and the obstruction. One thing I wanted to note here is that even with breakaway hardware, so like a breakaway luminaire signs, luminaire support, a signpost, or an I-beam sign, none of those should be located within the deflection zone of your guardrail. There's not been any testing that I'm aware of where we've tested the interaction of guardrail deflecting into a breakaway device. We don't know how it's going to react. So in your designs or in the field, we need to make sure that we're locating that breakaway hardware outside of the deflection zone of guardrail, even if we're installing it behind guardrail. And there's situations where, you know, we have existing guardrail for a slope or something, but we still may be installing a breakaway device in that area. You know, different guardrail applications, type 131, the 231, which is your half post spacing, and then we have the 331, which is median guardrail. One thing to keep in mind with the median guardrail design is that we are required to use 8-inch offset blocks with the median design. That's based on the MASH testing, so that's in the new standard details. The 131 and 231 will use the 12-inch offset blocks. On the guardrail placement with respect to curb, you know, there are curb tolerances as far as lateral placement, as well as the curb height and the height above the pavement to the top of the guardrail, which is covered in the details. One thing I wanted to note here through some inspections is we want to make sure that at a minimum, the face of the guardrail is flush with the face of the curb, but it can be set back no more than 6 inches. So no more than 6 inches from the face of the curb to the face of the guardrail, but ideally we want that to be flush with the face of the curb. On your median guardrail details, as I said, 8-inch offset blocks only. We have the new curb if curb is called out on your plans. There's the new style curb, type 1-2 curb, 6-inch concrete curb that's used. And again, that's flush with the face of the guardrail. One thing to keep in mind is when we're installing guardrail in lower speed situations, and it's going to be offset from the face of the curb. We have allowances to do that, but the height of the guardrail with respect to the top of the curve at the edge of the roadway, and then with respect to the top of the ground line directly at the face of the guardrail is key. And based on crash testing that needs to be at the top of the curb, the guardrail height can be no taller than 32 inches, so 31 to 32 inches. When we get to the face of the guardrail height in relationship to the ground level at that point can be no more than 34 inches. So when for grading, we need to make sure that that is taken into account. Again, these are in low speed, less than 45 mile per hour conditions. If you're higher than 45 miles per hour, your guardrail has to be at the face of the curb. John alluded to this a little bit in his presentation earlier about omitting a post and the leave outs associated with curb openings, those types of things. One thing we did to try to alleviate that issue is add a guardrail with omitted post detail. That is now detail B1, sheet 4. The guardrail, the post is omitted within the run of guardrail. It's one post that is omitted, and the specific location of where that post could be omitted is based on its proximity to a guardrail end treatment, a transition area, or to the end anchorage. So they can't be within a certain amount of distance from the nose of an end anchorage or from the nose of a guardrail end treatment. All that is shown in the detail. The other thing is with curb, if there's curb present, the guardrail within the area of the omitted post needs to be nested, meaning you have to have two sections of rail nested one inside the other in that area as shown in the detail. When curb is not present, we don't need to nest the guardrail in that situation. Here's just showing the detail of where the posts can be omitted within proximity of an end terminal or an end anchorage. And then looking at it from a couple different options when we're omitting posts, we have the guardrail with omitted post option. We also have guardrail over culverts, and really the guardrail over culvert is reserved for areas where we're literally spanning a culvert or a pipe or something like that. We can do unsupported span lengths between 12 feet and 6 inches and 25 feet. The max span length is 25 feet on the guardrail over culvert. But if we literally need to just omit one post, we now should be using the guardrail with omitted post detail, not the guardrail over culvert. And the difference is the type of posts that you're using. So in the guardrail over culvert, you're using the breakaway wood posts on either side of the opening. And in the guardrail with omitted post detail, you're still using steel posts. You're just literally omitting one post at that point. So here, in these situations, we've got curb openings. Again, the intent here is to omit if the post is within the curb opening, you now have a detail to omit that post. We do have options for leave outs, which I want to talk about in a second. But we also we don't want to install the guardrail over culvert detail in this situation here. We've seen some situations in the field where that's been done. The other thing to do is look at, and again, I think John pointed this out as well, is look at your layout in design as far as where your curb openings are going in relationship to your guardrail posts and trying to avoid putting that opening in the area where a post might be installed. And that can sometimes be difficult in design and even laying it out in the field, but we want to try to avoid that as much as possible. Related to leave outs. So we can use, if we have to omit or if we have to install a post in a concrete area, like let's just say a curb opening as an example. The post can be installed in that concrete, but we need to leave an area around that post that's not in concrete, and that'll to allow for the post to rotate upon impact. And the roadside design guide does cover this, and a lot of that was just based on NCHRP 350 testing. There was actually some recent MASH testing done by TTI that looked at both steel and wood post guardrail systems. The testing for the steel post guardrail in the leave out that passed for both the car and the truck, so it meets test level 3 application. The wood post test failed the pickup truck test. So in the situation right now, we can only do a steel post with a leave out, not a wood post. And the leave out area around the post requires a low strength grout. And the testing included it was a 1-part type 1A cement, 14 parts sand, 5 parts water by volume, no additives. I put a link to the presentation, to the crash test report on the slide here from TTI that talks more about that information. But basically, it's a low PSI grout that's installed around the post for these leave outs. And again, that's designed to allow the post to rotate and deflect upon impact. That's just a picture from the crash test there. Another new application, I guess, based on some lessons learned in the past, looking at where we install guardrail on steep slopes and trying to give us a little bit more flexibility related to grading around the guardrail. So we have the type 131 on a steep slope detail. It's sheet 5 of the V1 series. This allows us to install face of the guardrail at the hinge point, and the post is installed on a 2-to-1 slope. So there's guidance on how to use that in the detail. One area we wanted to focus on a little bit is grading for guardrail end treatments, and just a reminder of the different details we have for that is detail B2. There's 3 sheets. Some of the end treatments may have, the manufacturers may have specific grading requirements, but these are generally uniform amongst the various types of guardrail end treatments that we install on our roadways. So this detail obviously lays out the grading that's required in advance of and through the end treatment limits for placement. It's the type 231. And then we made some substantial revisions to the 331, the median end treatment, to provide some advanced grading, a 50-foot minimum transition area in the median for advanced grading into the type 3 end treatment as well. Some things to note here is we want to make sure that we're depressing any curb in advance of the end treatment. Needs to be no taller than 2 inches for 50 feet or 75 feet in advance of the nose of the end treatment and through the limits of the end treatment itself. And also, when you're looking at just guardrail placement in general, look at do we need like in this picture here, do we need all that guardrail, or can we just minimize how much guardrail is placed there and just use an impact attenuator to shield the bridge pier there? So that's one thing I wanted to point out with this picture is besides the curb height is we might have been able to get away with a less installation here and using a guardrail or a impact attenuator to shield that bridge pier. Some other common issues associated with guardrail end treatments, again, making sure that our grading meets the details. The intent of the grading is to minimize overturning of the vehicle and make sure that when the end treatment is struck, it can function properly and not cause overturning of the vehicle because the grade behind the end treatment is too steep. Again, curb must be lowered or eliminated per the detail. We want to make sure that the area behind the terminal is also free of objects as well, because we don't want, if we have a gating guardrail end treatment and we have a low angle impact, we want to make sure that the guardrail, when it gates or when it's moved to the side by impact, that it's not obstructed by another fixed object, which could cause it to react improperly. End treatments should be installed per the manufacturer's instructions. If the system uses a strut between posts 1 and 2, that strut must be at ground level. John alluded to this already, but the bearing plate must be oriented properly. And we need to make sure that we're putting, if there's a flare allowed for the end treatment, it's installed per plan, per the manufacturer's details. Some manufacturers and certain devices will only allow up to a 2-foot flared offset, whereas others may allow up to a 3-foot offset. So you make sure you don't offset it too much because then it may not react properly in a crash. Some new style end treatments that we're seeing in the field. The Trinity should be soft stop. Trinity soft stop. This is the top right picture there. This is slightly different than some of the end treatments that we're used to. In some of the previous designs, the guardrail ribbon that would be extruded through the head is extruded out to the side, whether it's on the roadside, away from traffic. Some devices allow it to be on the traffic side. But the Trinity soft stop actually extrudes the rail out of the bottom of the guardrail head there and it's intended to lay it flat on the ground. So it keeps the ribbon from impacting the vehicle during the vehicular impact of the end treatment. One thing to note here is that posts 1 and 2 are not installed in line with each other. So post 1 is generally offset of post 2, and that's based on how the system functions. So if you see that if you see post 1 and 2 are offset from each other and it's not installed, it's installed correctly. It is not incorrect. So just keep that in mind. The other one that we've been seeing is the max tension from barrier systems, which is the bottom picture there. This is an energy absorbing end treatment. There's a coupler that's 3 or 4 posts downstream, which absorbs the energy of the impact and cuts the downstream rail sections. And that's the portion that absorbs the energy and reduces the energy on the vehicle. One thing to note here is that there are special bolts for that coupler, and those must be installed correctly for the system to work properly. So installation and maintenance, that's important that those bolts are installed properly on that system. On some transition notes, I wanted to point out here, we have the detail V7 that allows us to transition from 131 to 127. We've not seen this done, 100% properly in the field in certain situations. Sometimes we have things like this. And we want to make sure that, we're properly transitioning the height of our guardrail. This picture might be slightly extreme. But I've seen situations where we have 31-inch guardrail at a sign structure, and then really just the rail element on either side of that is just literally transitioned down to the 27-inch height, and it should be in about 28 feet for transitioning the height, and you're also transitioning the splice location in this situation. So for the 31-inch guardrail, we're transitioning the splice from mid-span to the 27-inch where the splice is at the post. So keep that in mind as well. It's not just transitioning the height, but you're also transitioning the post location. Just a reminder of the new V10 guardrail to barrier connection, the Type 331. This is it has a transition from W-beam to Thri-beam, and then that attaches to a concrete buttress. And that concrete buttress is designed to go from a flat surface to match the shape of your bridge barrier downstream. So it goes to an F shape or a single slope design. So that's in the details as well. Just a reminder that that's available for use on new construction. Some design considerations for this. We have the Type 131 approach guardrail transition, the older style W-beam. That's to be used for existing F-shape barrier wall attachments, retrofit situations. The new detail is to be used for new construction or where it's desirable to construct the concrete buttress. And if there's any questions about that, you should consult the MASH committee for that situation. One reminder related to barrier hardware is related to the guardrail reflectors. We did add the notes. There's been a lot of questions in the past years about the color and placement of the guardrail reflectors. So we did add the notes to the detail. But just a reminder, make sure you're adding the reflectors to your guardrail. No reflectors are to be installed within the limits of the end treatment. And that's within the pay limits of the end treatment as shown in the detail B2. Generally, if it's a 2-lane road, your guardrail on the outside is going to have white reflection on both sides of the reflector. And then if it's like a divided highway, the left side would be yellow facing traffic, red facing the wrong direction, and the right side would be white and red respectively. Okay. Barrier. Again, looking at the new details, we have new concrete barrier details that are available for use. We have 36-inch F shape and 42-inch F shape roadside concrete barrier. And then the median, we have 32-inch F, 36-inch F, 42-inch F shape, and then a 42-inch single slope barrier. Those are available for various needs for projects. And then just a quick reminder on the approved products list. We have an approved products list for guardrail end treatments and permanent impact attenuators. These devices must be used on our projects moving forward now. And I believe that's covered in the specs and should be covered in source of supply as well. But if there's a question on what's allowed, just refer to the approved products list and that will show you what's currently approved for use in the state. That, I believe that is it.
Okay.
So I will take if there's any questions in the Q&A.
We got time for a couple questions.
Yeah.
Two of them. Curb guardrail section, standard construction detail B18. Is there any idea when the 31-inch height guardrail detail will be available?
So there is a design available, but it's very, I don't know the best way to put this. It's not the best design that's available. So there's been a lot of match testing on this system. And really the issue is the head-on impact into the curve section of guardrail and to minimize damage due to rail rupture. A lot of testing has been done with sand barrels behind the guardrail, and that requires a lot of grading behind the system to place the sand barrels and to allow for run out when the vehicle does get behind the guardrail. I think we looked at this during the standard details update, and it was decided that this was this wasn't the best solution for us to use right now. So we opted to maintain the existing detail and monitor crash testing. And there's not been a lot of crash testing since then, so it's something we're continuing to monitor.
Next question. Is it acceptable to omit a post in a dual face guardrail installation?
There's been no testing on that, so no, it is not. Good question.
And that's all the questions we had. So,
and one other thing to note, there's with guardrail transit, the guardrail transitions to barrier. That's another thing that we're missing right now is a transition from the type 3 guardrail into a medium barrier situation. There's no tested transitions for that under MASH. So whatever's been done under 350 would still be acceptable in that situation.
all right. Thank you, Adam. All right, so we're on to our last topic of the day. It's on the pipe inspection and remediation guide. Mike Nauman's unfortunately not able to be with us today, but he pre-recorded a presentation. We're going to run that now.
Good afternoon, everyone. My name is Mike Nauman. I'm here today to present to you on the newly published Pipe Inspection and Remediation Guide. Before I get started, I just want to say thank you to the industry members and the department staff members who assisted with the creation of this guide. It was an extremely collaborative process and a great team effort. I am very proud to be here today to present this guide, which I know our entire project team thinks will be a great tool for the department moving forward. I always like to start these types of presentations with a discussion of how we got here. Performing a pipe inspection is a critical element during both the design phase and the construction phase. During the design phase, it is important to review the existing drainage system to determine if the system will be adequate for use in the final drainage network. Likewise, performing inspection during the construction phase is critical to ensure that the drainage system is installed will achieve the service life that we are intending. The best way to achieve this in both cases is to look inside of the pipe. For example, wide joints discovered in a post-installation inspection can be a serious defect in pipes and could lead to premature failure. The best way to see these wide joints is to get inside of the pipe. Currently, the department is performing design phase inspections with in-house forces and performing post-installation inspections under our CI agreements. The excerpt on the screen comes from the 2020 standard specifications. The specifications state the department will be performing these post-installation pipe inspections, but is silent after that. This guide is meant to pick up where the standard specifications leave off and provide guidance to the staff who are charged with performing these inspections. One of the things that we thought was important was to put the mission statement of the guide in the beginning of the document. The mission statement of the guide was based on the feedback that we received from the various levels of department staff. Accordingly, the purpose of this guide that we came up with is as follows. Document DelDOT's policy for post-installation pipe inspection. Document DelDOT's recommended procedures for performing post-installation inspection. Document the requirements of staff performing these post-installation inspections. Document the submittals that the department will be requiring from these post-installation inspections. And finally, and most importantly, provide guidance to the department staff who will be evaluating the post-installation inspection reports. One of the items that we wanted to make very clear in this guide, it is not a contract document. The guide is meant to compile industry best practices and does not have contract governance. The example that I have on the screen comes from section 105.6, contract hierarchy of the 2020 DelDOT standard specifications. Nowhere in this list does it say pipe inspection remediation guide. However, one thing that we did want to do was to write the guide in a way that it could be easily referenced in any pertinent professional services agreements. For example, the department is currently performing these post-installation pipe inspections under their construction inspection agreements. We wanted to make it easy for these agreements or tasks under these agreements to just reference the guide when creating their contractual language. I want to next talk to you about how this guide is meant to apply to the various groups inside of DelDOT. We wrote section 1.1 entitled Pipe Video Inspections during the design phase to highlight this topic for our design groups. What we said is that this guide provides the best practices to follow as well as other general considerations. However, existing applications don't have to be measured to the same accuracy or precision as newly installed applications. And the reason for that is that the passage of time will have allowed any defects in the pipes to more clearly present themselves. One final item to highlight on this topic comes from our 2020 standard specifications. The standard specification states that the department will review all existing pipes for use in the final drainage system and will discuss the system's condition with the contractor before starting construction. These design phase videos can be a great tool in these discussions. We interviewed quite a bit of M&O staff during the development of this guide. The common theme was that the M&O staff didn't want a one-size-fits-all policy and insisted that the user really needs to consider the cost versus the benefit of performing a full post-installation pipe inspection. Working with M&O, we came up with a list of applications where we thought the department should consider providing a full post-installation inspection in accordance with this guide. We came up with the following items. Longer installations of pipe. Longer installations of pipe will inherently present the potential to have a larger number of defects present just based on the fact that there is more pipe in the ground. Also, longer installations would mean a relatively lower mobilization cost relative to the length of pipe installed. Higher traffic volumes. This becomes a factor in cases that there is a defect that goes undetected and leads to future failure and road closure that would be required to fix the pipe. Higher traffic volumes mean more delay and therefore create higher potential benefit to perform this inspection on the front end to ensure that we reach the service life of the installation that we desire. Locations where other available post-installation tools are not as effective. There are other post-installation inspection tools that are available for use. Two of those tools are shown on the right side of the slide. On the top is essentially a GoPro with a flashlight on steroids. It allows the user to look into the pipe from an access point to evaluate the condition of the pipe. The picture on the bottom right is of a mandrel. Mandrels can be run through a pipe segment to determine whether the installation hits a certain deflection limit. In flexible pipe, 5% is kind of the magic number. If the mandrel is set to measure 5% deflection and becomes lodged in the pipe when it is run through the conduit, it can be determined that there is a deflection defect. This tool is obviously more useful for flexible installations. The final item that we came up with the assistance of M&O, was if there were any documented issues during construction. For example, if a contractor was cutting corners backfilling, it might be good to go and to recheck them with a post-installation inspection to verify that the work is sufficient. Our construction group is really going to be the primary users of this guide. As I mentioned before, post-installation inspections are currently being performed under our construction inspection agreements. Our intent with this guide is to standardize the service we are getting in accordance with industry best practices and AASHTO recommendations, as well as to standardize the deliverables we are receiving. The primary purpose of this guide is to assist the DelDOT engineer administering these tasks. The guide is also meant as a best practice for any permitted work which will occur inside of the right-of-way. However, unless it's specifically called out as a term in our agreement for acceptance, The guide in its requirement does not have any contract governance. So what is in the guide? This is our table of contents from the guide. We pretty much covered everything that's in Chapter 1 and are going to move on to discussing the contents of the rest of the chapters. Chapter 2 is entitled Inspection Preparation and Procedures. This chapter walks the user through everything they need to know in order to properly set up for and then subsequently perform the inspection. This includes a brief discussion of the traffic control required, a discussion of setting up flow control, as all pipes should be inspected in a dry condition, as a discussion of pipe cleaning, as we need to have a clean pipe surface in order to be able to see and detect and measure all the defects, and finally, a discussion of the procedures to follow when performing a pipe inspection. These includes a speed limit for the rover and measurements to take at each joint and other industry best practices. Chapter 3 is all about the equipment that is required to perform this work. The goal of this chapter is to give a general understanding of the various tools that the engineer may see their CI using, as well as to give the engineer a good base of understanding of the industry best practices. One of the things that we recognize during the creation of this guide is that the technology and the equipment used to perform this work is always going to change. So we wanted to try to provide a good base of information and make the guide as easy to update as possible as technology is updated. For example, we wrote the discussion on camera requirements to be easily updated in the future. Chapter 4 of the guide is all about the deliverables that the department is going to require under the Professional Services Agreement. This is something we talked about with our construction staff as well as industry members to determine what is the information that is most beneficial to the department. Chapter 4 is going to require that the department receive a video for each pipe that is inspected. Please note that manual inspections will be allowed for pipes that are 48 inches and over. We are also going to require GIS data for the department's asset inventory and a storm drain report. We work with DelDOT to determine what elements in the storm drain report we should standardize with forms as well. We wanted to make it easy for the engineer as well as the CI performing the work to use the tools, but we didn't want over-standardization to become burdensome. This is an example of one of the standard forms we included in the guide. This is the cover sheet, which identifies all the key project information and should be the first page in the storm drain report. We created a quick flowchart to help the user understand how the guide fits into the post-installation inspection process. Plus, who doesn't love a flowchart? First, the drainage network is installed. Second, the post-installation inspection is scheduled in accordance with standard specifications. Third, the post-installation pipe inspection is performed. The construction inspection staff documents the defects discovered in accordance with the guide. DelDOT reviews the report submitted from the CI and associated documentation. DelDOT approves the report and agrees with the out-of-spec items and are sent to the contractor. The contractor reviews the report and provides recommendations for remediation. The engineer can concur or reject and can use this guide as a tool in that process. Chapter 5 through 7 is really the meat and potatoes of this guide. The department currently allows multiple pipe materials to be used on their contracts. The allowable pipe materials on DelDOT contracts are discussed in DGM 120 and is based on the desired service life of the installation. Different pipe materials have different characteristics and accordingly, different potential defects. These 3 chapters are intended to be a one-stop repository for each pipe material that could be used on a DelDOT contract. Chapter 5 is on reinforced concrete pipe installations. Chapter 6 is on thermoplastic installations, and Chapter 7 is on corrugated metal pipe installations. Each chapter is formatted similarly in that there is a discussion on the general characteristics of the material, a section on the defects associated with the material, a discussion on the general characteristics and considerations associated with evaluating a defect found in the installation, and finally, there are suggested remediation flowcharts, which are based on industry best practices. Chapter 5 is dedicated to reinforced concrete pipe. This chapter categorizes and provides a definition of the typical concrete pipe defects. The typical concrete pipe defects are joint defects, cracking, misalignment, and spalling. Pictures are provided for identification purposes, and a discussion is included on the severity of each defect type. The guide also includes several general considerations for the material based on the concrete-specific considerations. Those include autogenous healing, pH, installation stabilization, and differential settlement. Here is an example of one of the remediation flowcharts that is included in this guide. This flowchart is for concrete cracking. The flowchart comes from industry and best practices and matches AASHTO guidance. The flowchart is meant as a general tool. In all cases, the defects present should be considered individually and collectively. Now I'm going to walk you through an example of how to apply the contents of Chapter 5. We start with the contract documents, which in this case is a standard specification. This excerpt comes from section 601.3.3 C2, where the department clearly defines what it considers to be a defect. The department states the engineer will determine the need for remediation or replacement for the following reasons and provides a list. The example that we are going to use is going to be for cracking. Item E states that cracks greater than 0.1 inch in width are considered a defect, which the engineer will determine the need for remediation or replacement. Our example will be of a 0.15 inch wide crack with significant vertical offset. This will be considered a defect in Chapter 5 of this guide and will require the inspector performing the post-installation inspection to document and record the defect. The defect is also considered a location where the engineer will determine the need for remediation or replacement in accordance with section 601.3.3.C.2 items D and E. DelDOT receives the inspection report from the CI and agrees to the report's findings. The DelDOT staff can then provide the information to the contractor saying there are defects present that are considered out of compliance with the contract. The engineer can then use the flowcharts and the information contained in this guide to assist as subsequent discussions occur on the magnitude of the required remediation or replacement. For this example, let's say the department says that the contractor needs to replace the pipe, and the contractor says they only need to perform a crack seal that will count as a remediation. The engineer can review the severity of the crack in accordance with this guide. We start with the cracking flowchart. The crack is longitudinal, which means parallel to the bedding, and it is larger than 0.01 inches in width. And there is vertical offset across the crack. Accordingly, we are kicked into the slabbing defect flowchart. In the slabbing defect flowchart, we start with the question of, do we have slabbing? The answer is yes, based on our last flowchart. We then arrive to a decision point which asks for the magnitude of the defect and the potential stabilization of the pipe. You can see we are now in the ballpark of performing a structural repair or replacing the pipe. Therefore, crack sealing is not going to be sufficient. One last thing to note is that each choice in the flowchart should be a logical choice when read in conjunction with the contents of the chapter. Chapter 6 is all about thermoplastic pipes. This chapter is laid out similarly to the rest of the chapters where we discuss the defects associated with thermoplastic pipes and where definitions are provided for the defects. Also included is a discussion of the severity of the defect and pictures for identification purposes. We also provided a general consideration section as well. The general consideration with allowable joint gaps is that some manufacturers allow for wider joints than the criteria that is listed in our standard specifications. So even though the joint may be out of spec for joint gap width, it may not be out of compliance with the manufacturer's requirements, which would then meet the ASHTO requirements for a leak-resistant joint that we specified. We also included remediation flowcharts in this chapter as well. The example on the screen is for installation deflection. We're now going to walk through another example, this time for Chapter 6 in regard to installation deflection. Again, the department defines what we consider defects in section 601.3.4 C2. And we say that the engineer will determine the need for remediation or replacement. Item A states that we will consider a 5% deflection value as a defect. One thing to note, and was also mentioned previously, is that the guide is really meant to pick up where the standard specifications leave off. The guide and the standard specifications were coordinated during development so that they are in agreement on the defect types as well as the critical measured values that the department would consider defects. In our example, we'll look at an installation where the deflection is 6.5% deflection. I know the picture on the right side shows a lot more than 6.5% deflection, but I wanted to make sure everyone could see the deflection. The 6.5% deflection is considered a defect in accordance with Chapter 6 of the guide. Therefore, the CI would need to document the deflection in accordance with the guide. The defect is also considered a defect in accordance with section 601.3.4.C.2, item A, and is therefore a location where the engineer will determine the need for remediation or for replacement. We can go to the deflection flowchart to understand the industry best practices as well as AASHTO guidance for these instances. We start with the decision point of if the deflection is under 5%. The answer is no. We then go to the next decision point where the user is asked if the deflection is under 7.5%. The answer to this question is yes. The result of this analysis is that an evaluation can be performed to determine if the pipe is viable or if it needs to be replaced. This follows AASHTO's recommendations. Additionally, AASHTO documents the procedure and items that should be evaluated in these instances. The contractor can choose to perform this investigation to try to keep the pipe in place, or the engineer can dictate from the standard specification language that the pipe must be removed and replaced. One of the overall goals of the project was to allow flexibility where it made sense, but also to make it so the department didn't have to accept pipes that were not installed properly. We also included a chapter on corrugated metal pipe as well. The department removed corrugated metal pipe from the 2020 standard specifications. However, we thought that we should still include a chapter for legacy installations, as well as future installations where CMP is installed at locations where CMP is allowable per DGM 120. Because it's not in the standard specifications, and we kind of already went through the information before for chapters 5 and 6, we're not going to get into more detail in chapter 7. Chapter 8 is all about the various remediation techniques that are available. Our goal with this chapter was to discuss the more common operations and techniques rather than getting too specific on any one material or operation, and the reason for that is that these technologies will change over time. The goal of this chapter is to provide the engineer the base information about the various techniques, and more importantly, help the engineer understand in what instances the techniques can be used. In order to help the user understand how the various techniques are related to each other and to the work, we defined several terms. We defined two different types of defects. Localized point defects are defects that occur within the spot location of the pipe and are not applied linearly along the pipe. A linear defect occurs linearly along the pipe for a substantial length. We also defined two different categories of remediation. Trenchless techniques do not require an open cut to perform the repair. Open techniques require an open cut to perform the repair. Our objective was to focus on trenchless techniques, as open cut techniques are more straightforward operations and can also be inspected easier as they are performed. One item that will be of great help to the department staff looking at the various remediation techniques is Figure 8.1 of the guide. The figure helps the user visualize how the various remediation techniques are related to each other. You can see that we broke the chart down based on the open cut and trenchless techniques. We then broke the chart into whether it is a linear repair or a localized point repair. From there, we categorize the work on how it is performed. For example, under pipelining rehabilitation, we included the techniques of cured in place, centrifugally installed, and spiral wound, which are all considered pipelining techniques. We also included a brief discussion section on each method to help the user understand the principles of the techniques. One of the items that the project team performed under this task was to write several special provisions for the department's use. Our goal with developing and organizing the special provisions was to dictate to the contractor what the department requires in terms of a service life of repair, as well as what type of repairs they will be performing as either in a linear repair or a spot repair. However, we did not want to dictate the means and methods to the contractor. The thought behind this is that there are numerous techniques available to perform the work that the department is requiring, and any one of these techniques could be the most applicable technique based on the site conditions. The special provisions can be used by the various sections of the department in different ways. The construction group can use it as a reference when remediation work is to be performed post-installation. The design and M&O group can use these special provisions on their design projects or on their open-end agreements where pipe remediation work is part of the scope. The industry members that we talked to are very excited about these special provisions, as they thought these special provisions would allow them to better address the department's needs. I also wanted to provide a real quick synopsis of the special provisions that we wrote. We made two items based on internal pipe point repairs. The breakout in size is based upon the techniques available for the two different size ranges. Applications that are between 12 to 42 inches are typically performed by robotics, and applications where the pipe diameter is greater than 42 inches are typically performed by man entry. External point repairs is the old dig and wrap pipe separation special provision that the department has been using with a few minor modifications. Finally, we also created special provisions for linear repairs as well. We broke these items out based on different pipe sizes to try to help the department achieve a better price history. We also categorized the repairs based on whether the repair is required to be a structural repair or a non-structural repair. Structural repairs should occur where the structural integrity of the existing pipe has been compromised. In these applications, the liner is designed to take the loading associated with the application. Non-structural liners could be used in applications that essentially just need to be sealed and where the structural integrity of the application has not been compromised. We embedded several videos on this slide that show the various pipe remediation techniques we discussed today being performed. If you're a pipe nerd like me, I encourage you to watch. Thank you everyone for your time today. Please feel free to reach out to myself or to Barry or to Oz with any questions you have on the guide. Thank you again to all the staff and industry members who contributed to the development of this guide.
Thank you, Mike, for preparing that presentation. Just a couple announcements as we wrap up the day. You should have received an invitation for tomorrow's session from Sandy Wolf. Tomorrow's session begins at 8 o'clock and runs to noon. We're going to be talking about things like Unifier, Stormwater and E&S, a couple bridge projects and lessons learned on those, and EDA and e-ticketing. So those are just the highlights for tomorrow. Again, beginning at 8, ending at noon. If you are not able to attend, please complete your evaluation by Friday. And I just want to say thank you to all the presenters today and thank you all for attending and have a good night.